Morning. Today we're gonna continue, you know, creating the banking system in Java, and also we're gonna review some of the lead code questions because I figured it would be great if, like, today I'm gonna also stream a study with me session actually, um, but also during the main stream I wanna review the some of the lead code problems that we have solved earlier. All right. Um, so let's open our notability. And good morning, guys. I hope you are doing just good. And also, I think we should also find the project that we have. I think it was here, right? In companies? No. Hands-on projects, I think. And yes, this is our project. So let me create. Let me open a new session for our cloud, and we should copy this one, and we should activate our skill. What was it again? Active build or something. Adaptive build. So activate skill. We are gonna continue creating this. So let me let me activate the skill because this skill is the key. Let me update the topic as well. Topic is review if you leetcode problems. And also let me open the stream on my phone just to make sure everything is okay. Also, maybe we can move these pencils over there. It seems nice. Let's see. I think we can add a background sound too. Oh, and just make sure we are using correct microphone. Welcome, welcome, welcome. Let's see. All right, now the sound, the voice should be better, guys. think everything is good now. Welcome, Americano. Good morning. How are you doing? How are you feeling today? Audio is good now. Yeah. Like at first, like it was using my laptop's microphone, so that was a small mistake. Alright. Today, I've I'm doing great. The sounds of Sisata is just best thing to wake up on. Also at break. What does meaning of what is the meaning of Sisata? Let me find it. Ah, I see. Alright. Also at break. What do you mean at break? Like I figured today if we like a review a few lead code problems, that would be awesome. There was an ad. Ah, ad break. Alright. Got it. Got it. Now we are free. So I figured it would be great if we review some of the little questions that we have solved. Alright. What sort we have? Happy number. Oh my gosh, the ugly question. Let's review set matrix 0, alright? What do you say, Americano? Today, after this, we will continue with developing Java. Sounds good. Sounds good. Amazing. So, and also maybe I can open our website RL as well. Let me open it too. Let me host one. Alright. The room number is this. Let me share the link as well. So we have our room 2. Alright. So set matrix 0. So what was that question again? Alright, so in this question, like we were making everything 0, I think. So we were making the row and the column of zeros, 2 zeros. But what was the trick? So if we find all zeros and record their rows and columns, alright, like a row addresses and column addresses, and then go and make those rows and column zeros, that will be that would be all. But I think it was, and there was something else too. Let's see. Do you remember this question, guys? Like imagine we have 0 here and the row is 1
and column is 1. So let's store this in a set. All right, because imagine you have another 0 over here, and imagine you have another 0 over here. So its address is, let me use another color. Its address is row 0 but same column. So if we use set, like, we wouldn't need to store this because we already have this knowledge. So imagine we have zeros over here, 1 0 over here, and its address is row 1 column 2. So we already have this. So I think the idea was kind of like this, alright? So storing the addresses in a set, like we need some sort of a for loop, iterate everything to locate the position of zeros and store them in a set. Like, I think this was the idea. Yeah. What do you see here, guys? So for each starting from 0, for loop starting from 0. So like, so the other for loop, like, let's say we stored these, and in the next for loop, now it is time for setting phase. So we have the addresses. Now how do we, so we have another set for row, set for column. I think we would iterate all rows and all columns, and that's all. But how do we do that? How would we do? So isn't red row 1? No, the red row. Smoker, good morning, Smoker. 1 2 3 4 5. How are you? Welcome in. We are reviewing some of the questions we have solved earlier, and then we're gonna continue with building a banking project in Java. Like, red is like a row 0, column 1, Americano. Since row is horizontal, yeah. Now let's see. Oh my gosh, I'm gonna fix this bug soon. Wait, no, I'm still sleeping right. So setting rows, alright. Exactly, you nailed it. It's the correctness problem before it's an optimization problem. The zeros you write look identical to zeros that you were originally. So I think this is the problem. This was the problem that we need to solve actually. But now I don't see that problem. I mean, like, let's store the addresses in a set, basically. Mm. And then in the second for loop, just set them to 0. So this seems legit, right, guys? The problem we have, I mean, current problem is set matrix zeros. This is the question, guys. Question 73. That's interesting. Let's go on. And so first pass, all right. I guess this is how far we we have gone. So in loop 1, I see headset here. So nested for loops necessary for since as necessary for our 2D array, we store, and I don't see the solution over here. So let's look at the what we have written. The part where this question is interesting is brute force approach overrides feature, so we can't do in place. Oh, got it. So this was like if you see zero, set its entire row and column to zero. Yeah, yeah. That is the question. Yes. The problem distinguishing the original. So the solution is two passes. Yeah, yeah. Like I think the thing I just described is the solution. In first pass, store the addresses in a set, and in the second pass, color them. All right. Oh my gosh, this is disturbing. Let me actually move this to another page so that you don't see it anymore. All right. Good morning, bro. Welcome, welcome in. How are you? Doom Python, I think. We are reviewing some of the questions that we have solved earlier, and um, and then we're gonna continue with developing a banking system in Java. Let's continue. We have three some here. Oh, the solution is taking snapshot once exactly and processing um based off the snapshot. Yes, yes, in two passes. Yeah, yeah, we talked. Yeah, yeah. Like I was gonna send you a message, but like there was little time, and I wanted to start my stream on time, so I couldn't send you a message. But yeah, I know you. I know you. Welcome in. Greetings to India. So another problem, like this threesome, and what was that question? Let's. You wake up from, yeah, yeah, yeah. You can you can hear it from my voice. I just woke up, wash my face, brush my teeth, and wash my face again because I need to, wake up with cold water, and yeah, take a one sip from my water, and I just started. So the problem, this is, so this is, I think, like a next version of two sum, and in two sum we have an array of sorted integers, right, guys? And we have two pointers starting from left and starting from right, and they were going inward, and the inward. I think the idea was, since it is sorted, as you go inward, the number will increase if you move your left pointer, and if you move right pointer, the number will decrease. So the thing, like, we need to update, we need to change our formulation. Like, same idea, but here we have three. If you don't mind, you can increase your OBS volume, um, the background, or the microphone. The, the microphone is currently at the microphone is currently 0 dB, but since it's too early, I don't talk that much. But after 2-3 hours, like in 2-3 hours, I will talk a little bit, higher and more. Thank you for saying that. The mic is currently, at max level. So that's why I hold my microphone to my mouth actually. I figured you hear me better this way. So we have these numbers and we need to find these triple that equals to k. And instead of, okay, try to find these 1, I guess we were like reducing this or transforming this into some, oh actually this is not k but 0, it was 0, and we were transferring these, like this formula, to this one, and then now our problem is exactly like two sum. So what else do we remember, guys? What else do we remember? um I think that is it. So we sort our array and start x from left and start y from right. What do you say, guys? So we, it is already another problem. Another problem. There is some like this problem. Um, this. Do you remember this? This one. Like, yeah, remember it. Yeah. So then if you remember, fermented beans America. If you remember, how about you type the solution Americano? Come on, type your question over here. We want to see some code. No, all right. We just woke up. So I think I think yes. So, but the thing I remember, like the thing I realized that we literally make, I mean, left as, I mean, x as left pointer and y as right pointer, left pointer and right pointer. Oh, cool. I will try to solve with you next, but I'm gonna sleep in. All right, all right, all right. No worries. Thank you for stopping by. So this makes like, this made me wonder, curious, because I think it won't matter, because at the end the thing we try to find is like finding two numbers. So we basically start from left and start from right and try to find this number basically. Let's see. Let's see what we have written. Sort, like sorting is important, guys, because we build logic on top of it. And then fix one, 2 pointer on rest. Yes, so this is what we have done. Skip. So maybe another part of this question is skipping duplicates, but like I don't see any duplicate issue right now. Let's see. Oh, all right. We have our numbers array, integer array, and we return list of lists. That's fine. The first solution we have done was, giving this error, throwing this error. I think this is the solution we have came up, come up. We have a for loop over here where, so the endpoint, for example, this is one of the details. The endpoint, like we don't like process. Let's say you have this array and you are trying to find triple. So you start from 0, but you don't process the last one, I guess. That's interesting. Well, what was the goal of this for loop again? Because the solution I had in my mind was like just sorting the array and start our 2 pointers from left and from right. But we didn't think of the um, like an endpoint for our for loop. Let's see. Uh, so 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 these are 2 pointers basically. So we sum them up and we try to find the negative version of z, because as you know, because when we sum these z and x and y, then we're gonna have 0. So this is our rule, and this is our 2 pointer thing. But I I I I didn't figure out the meaning of this, but we're gonna understand. Um, let me. So we are creating an array list here. So if we find our goal, if we reach our goal, then this is a triple that we need to save basically. We create a list, and so this part is for duplicates, guys. And I remember we have spent a lot of time with Americano just to write this part. Right, Americano? Do you remember? Do you remember? So, like, I figured that duplication is not an easy job, you know. Let's skip this part. We can come back. Basically, we have 2 pointers starting from left and right. So where is this start point again? Partially, I need at least certain history. All right. That's fine. Like but what is the start point of x and y? Where do we start them? I think here. AFK for 5 minutes, need to get Kohi. Alright. Take care. We'll be here. We'll be here. Um so the start point of y is end, like a last location, and start point of x is z plus 1. So guys, like imagine we have a sorted array, alright? So we first set z to this one basically, and then for the remaining part we apply 2 pointers, alright? And then we move z by 1, alright? 1 2 3 4. So we move z by 1 and set it to this, and then we apply 2 pointers to here. So alright, so this is what we are doing actually. Alright. Alright. So that's why the end position of z is not 6 but 4. But that makes me think that what if we lose? Like what if the result, like at the triple, is z equals 6 and I don't know, x and y like is kind of this one. So this is the question I have in my mind right now. Actually we can ask it, because we have AI in our side. Did we wrap up the last session? Checkpoint this session. All right. Let me ask this to AI. All right. In this solution, the thing like this is there is some problem, and the thing I wonder is in for loop we make z start from 0 to the last two position, and for the remaining, like after selecting z, for the remaining part we like we set x z plus 1 and y as the last element, and we literally make two pointer search approach to the remaining part after selecting z. But the thing I wonder is what if the triple is x being the last element and x and y being, you know, the other element? So like I don't like this made me think and worry about that part. What do you think about it? So because this is like this can be true, right guys? This can be true. The z could be you know, the last element. So let's see the our actually what other nodes we have. Actually we don't have any other nodes, but I wonder why I haven't add that part. So the remaining code is for recognizing the duplicate basically. Let's see what AI says. So good worry to have. This is exactly the kind of thing that should bug you until you can prove it can happen. So let me turn it back to you with one question. Take any valid triplet, 3 indices. Alright. In your sorted array, which one of those 3 is the smallest index? So I. Can a set of 3 distinct indices have 2 different smallest ones? So this is a question that we need to answer, guys. So like one thing about this question is like like recognizing the duplicate triple. This was something, and the other and maybe even the bigger one is understanding, internalizing this part. Can a set of 3 distinct indices have 2 different smallest one? I guess it can't. But how do we explain it and how do we prove it? Now connect it to your loop. Z walks across every index from 0 to n minus 3. So when Z lands on the smallest index of that triplet. So it says that like imagine we have like a triplet basically, x y z, and imagine we have the small, so let's say z in our case. For the remaining part, the numbers, the tuple we find, so when z lands on the smallest index of triple, where are the other two relative to x? Z, like in the current version of code, they are on the right side of z basically, because we make them. But where do you want to go with this information? And also, can you show me this info with examples? can a set of three distinct indices have two different smallest ones? So can you please explain it? Like, we need to see it, guys. Like, this is important. So, right, let me show concretely. Say the sorted array is this. Alright, a triplet is really a set of three indices like 1, 3, 4. Can a set of three distinct indices have two different smallest one? Like, I would say yes to this question. Alright, so let me copy this part and save it over here because it is important. An important thing to know in this quest is this, and then the other one is finding duplicates on two triples. So these are the two things, two hardest thing about this question, because the remaining part is basically two sum. Pick any three distinct integers, sort them 1, 3, 4. There is exactly one. That's the minimum. You can't have two smallest. Oh, that's interesting. One of them always wins. This is just property of ordering numbers. Three distinct values always have a unique min. Alright, maybe I can take a screenshot of it. Alright, why that solves your worry? Your worry was, what if the fixed element should be what if the fixed element, yes, so this was my worry actually. But watch what your loop actually does. It doesn't fix the first one, it fixes z, the smallest index of the suffix it's about to scan. Yes. Now I get it, guys. Now I get it. Because like even imagine, like, z doesn't need to be, guys, 6. Alright, this what it tries to tell us. Like, it is strange that z doesn't need to be 6, but the thing is, we are trying to find triplets. So like, take an example of, like, give us a triple, alright, that contains 6, alright, and in any of them, for example, 3, 5 and 6, 3, 5 and 6, in this triple, just focus on the minimum one, alright, it is 3, so it can be 4, 1, 2, but and the triple is also sorted. I partially get this part, guys. I partially get this part, but it has something to do with the minimum number that in a triple we can get. But then the next question is, why z needs to be the minimum in that case? So now this is my second question. Thank you for the amazing explanation. But now the like I have read the first part of your answer. But now the thing I wonder is why Z needs to be the smallest one amongst I mean amongst this triple. Because I feel like Z should be like we should have a triple where Z is equal to 6. What is wrong with that? Like I guess um there is no triple where Z is 6, right? But why? Like you literally said that it fixes Z, the smallest index of the suffix it's about to second. So act like in my mind, this for loop, with this for loop, we set and we were setting Z basically to any number. So we basically try to find every triple, but here we are saying that we literally set zx the smallest one, and if we do that, then your explanation will actually make sense for me. What do you say about it? Before sending um, before sending this message, let me, oh my gosh, we we couldn't manage to send it, but let me copy this part and paste it over here. Now let's read it. Why that solves your worry? Yes, this is your worry was, what if the fixed element should be the last one? Yes, not the first. But what your loop actually does, it doesn't fix the first element of the answer. Yes, so like this is what I was thinking exactly. With this for loop, guys, with this for loop, which for loop? This for loop, we are not setting the first element of our triple. There is another logic behind this. All right, it fixes Z. All right, so I mean, you already have taken a screenshot of it, right, guys? Like this is quite important. This is quite important about this question. I think the first time we were solving this, we didn't catch this part, but this is the important part. Um, it doesn't fix the first element or answer. It fixes Z, the smallest index of suffix. Oh my gosh. So this is the part where it is too crucial, guys. Important part. Alright, let me get rid of this line. Alright, this is important. So walk through every triplet and ask who is its smallest index. So basically, to be able to solve this problem, we obviously need to analyze a few triplets. So in this triplet, the smallest index is 0, and then in this again 0. So it's found when z is 0 and 2 pointer, yes, yes. So what is the meaning of this? What's the meaning of this? For this triplet, we set the smallest. Like, so what? So what? Let me paste it. Since z loops over every index, every triplet's smallest index gets its turn. So like this is one liner, guys. This is one liner. Since z loops over every index, not I mean to where like n minus 3 basically. Every triplet's smallest index gets its turn as z. This is it, guys. This is it. I have found our one-liner. Because at first I thought that we were just taking like a z value from our array input list without any logic, but we have a logic. The one-liner. So this is it. And the mistake I was making is it doesn't like I thought that it does fix the first element of the answer, but it isn't. It doesn't. So the mistake I have done was, I think, yes. Let me turn these like a at a boolean or something. All right. So I got it, guys. We got it. We got it. So this is one liner. Since z loops over every like a 0 to 1 of every triplet's smallest index. Amazing, but I wonder how do we like what should we have like what should we have added here? I mean, it would be great if we see the endpoint, like if we see something for representation of endpoint. So let me ask this and then we can continue reviewing um, this part. And for this part, what could we use for and index? You said 0, 1, 2, and but I don't see an endpoint. Let me. Alright, let's see. Two separate questions hiding in here. Let me split them because both are good. Why is z the smallest? Actually, guys, like z, like we don't specifically set z as the smallest, but imagine in any triplet that we could get, like in any triplet, there will be a smallest one, all right? And z is representing those basic. And this is actually right. I thought we set z to any number, meaning that I thought that it fixed the first element of the answer, but it doesn't basically. You're right that the for loop sets z to every index. You did not declare z is smallest, so does it end up being smallest? Look at where you let x and y roam. Y starts at the far right, yes. Every pair x and y, the two pointer, can ever pick has both indices greater than x because x, yes, yes. So z being the smallest isn't something you commanded. It's the consequences of confining x and y to the right of z. Whatever triplet this iteration produces, z is automatically its minimum index. You get z is smallest for free. Yes, but alright. That's the whole trick. You are not searching all triplets where z is anywhere. You are searching all triplets whose smallest number is z. And since Z sweeps every index, you cover all triplets. What is the endpoint? With no end. You actually already wrote the answer in your code. Yes. Here's the reasoning. Um, for Z to anchor a triplet, it needs two elements to its right. Mhm. Z can be at most third from last index. If the array length is so inclusive, which your loop, so the direct answers your. But I wanted to see how we can represent this. All right, I think we got this too right. So the thing I understood, guys. So basically, we set z, we take our z to minimum of our triplets, and minimum of our triplet can be, I mean, like can go to the to from and index. This is its farthest way that it can go, because like z is the definition, like we definition we use for z is the smallest of those triplets, any triplets that we need to find. That's it. All right, let's continue with edit distances. uh like yesterday I have thought about this question, and I figured that there are some questions that, like, where the options are not clear, and you need to, like, your job is to defining what are your options, what your options are. But here in this question, the options are cluster clear, but the thing we need to find is how can we um, do these operations actually. All right, what I mean by that is, let's open the question again. We have like a two strings, word one, word two. We basically want to convert word one to word two. All right, and it asks what is the minimum number of operations to do that. Let's see. So we have word one. We can go with example horse rose. All right, horse rose. So this is word two. So the operations we have is like a, let me draw the decision tree. Drawing the decision tree is, you know, easy in this question. We have insert, choice, delete, and replace. And like, if you have watched that stream, guys, we all also created an animation for this problem. Do we have like, did we paste it here too, or yes, we have it too. Uh, hold on a sec, guys. I think I am back. So these were our options basically, and the thing we need to find is how can we represent these operations um, using pointer arithmetic. So like horse and rose. Let's see. We have horse and rose. So let's see the condition we have to convert it. So basically we shouldn't have any unmatching characters, right? So let's look at it. Like they are unmatching. So we need to like we like imagine, guys, it was like or or and os. Like when they match, the operation we need to like, and also like the the thing is here, guys. We need to use pointer one and pointer two. All right, this is quite important. Pointer one on the first index, pointer two on the second one. So because we need to you know where we are looking at. Like I draw this line because I know that I am comparing this one and this one. So to represent this in code, we need something pointed. All right. Let me skip the break. All right. So this is the translation phase. All right, and it is important. When they match, they are matched. The thing we do is like only increasing pointer one and pointer two. Why? Because there is no option that we should take here. They're already matched. We should go forward. We should make pointer one and pointer two go forward and process the next characters. All right. So that's why we move two of them. But in the case where they don't match, like when they don't match, now we have three options. And the first time I was solving this question, I thought that I need to find some weird like a style of operations. But the if you know that what you only you need to do is finding how you move these pointers back. Which question is this now? This is uh, edit distances. We have studied this question. You remember, right? Where we have like three options, three choices we need to make. Americano. Uh, so now, oh yeah, this one. Yeah. So when the characters are matched, we just increase our pointers, right? The replace, delete, and one thing, insert. So when they match, the only option is this. When they don't match, this is where things get interesting. So we need to find a way to represent insert operation, alright? Let's see how we can do it. So horse and rose. So let me write it here again. Horse and rose. So obviously we want to transform this. So we need to do this insert operation on this one, alright? On this one, what we are gonna do? We need a position, obviously. So let's say at pointer one position, or it can be any position basically. Let's let's say which character. Like we have two questions here. Where are we gonna insert, and what we are gonna insert. What are we gonna insert? Where and what? What is we need to insert R obviously because our goal is turning this into this one. So we want the characters of this second string in the in our first string basically. What is R? So we need to insert R. Where this is tricky because it doesn't matter. So like imagine um, you add R here, I guess, right? And our string becomes H R O, like I think this one, right? I think kind of this one. Like in the animation, we will see better, but let's see. Um, Now is our string better than before? It is questionable. Um, but I guess it's kind of better because we have now this um order, this combination. We are now two matching characters. At first, at first we have only one, right? Like horse and rose. The only we have O, same. But now we have RO here in the first string and in the second string. So this is something good. Now our string one is kinda better than before, alright? And the struggle, like the pain point, it was where do we exactly insert it? The position of P1 or the next position? Actually, we can say P1, I mean P1 plus 1, where P1 plus 1, alright? At the end, this won't matter. I mean, of course, it is important, but we are gonna see. So, this is the insert operation, alright? And let's continue with this new version. And actually, after inserting, what should we do with our pointer 2 and pointer 1? Um, we we added R, right? We added R. So now we know that we have an R in our first string. So, and its order is good too, alright? Because P1 and P2 started from the beginning and we added R right away. So basically what I'm trying to say is we've done with R, like we completed its responsibility. Imagine this as a soldier. You gave an order to him and he completed his order. So we need to increase this pointer, right? We've done, like, it has done its responsibility, it completed its responsibility. Now it's time for P1. P1 was pointing to this character, all right? And now the size of our string is also has also changed. And like in this question we are building our answer dynamically. So let's see, what do you say, Americano? How should our P1 be here? Because in the animation, like, I remember something like we add a character but P1 still pointing to same character. So imagine like P1 was pointing to this, and we add R to P plus 1 position. All right, here. Now I feel like we need to increase P1 by 2 because um, it was pointing here, and now we are done with R. Now P1 should point to here and P2 should point to here. What do you say, guys? Like P1 plus 2 in the new array. But, guys, now I get it. Now I get it. We should add 2 if we are talking about the new string. But I think, guys, we are not talking about the newly created thing. P1 pointer and P2 pointer is on, you guess it right, on the original strings. So in the original we don't change. So I thought like like this is what I'm talking about, all right? Because like translation, this real world to into code is a skill, all right? Like we added R to our string, and now our pointer is over here. But in the original string, this is still like horse, all right? So so we have like we still have it like in original, like it was like this, pointer 1, pointer 2. We compared, we figured they don't match, and we insert a character over here. Yes, we inserted this character. Let me draw. We inserted this character, and now what should we do here? Since we are done with this character, since this soldier is completed his job, we obviously increase, and I think the answer is increasing the pointer 1 by 1 2. But what does it mean? Does it mean we are done with this one 2? I guess it's, I think there's some sort of shortcut we're missing right here. So I'll brainstorm for a bit. Yeah, wait, no, never mind, that's better than the idea. How about if you insert 1, then you also need to delete the previous one. Actually, Americano, the combination, like we're gonna apply different operations, all right? We can do like a insert and then delete and then replace, or insert, replace, delete, or insert. These are all possible answers, but we shouldn't think like this way, all right? We should think about our current problem and then the sub problem that we delegate to. Let's just replace dump. No, don't say that, by the way. And also, like we are currently focused on this insert operation, nothing more, nothing more. We are thinking how we can implement this insert and what is the consequences of inserting, and we are thinking in like pointer arithmetic way. Where do you where are we gonna insert that character, and which character? We figured that we should insert the character that P2 points to, because this is the thing that we want to see in string 1. And now the thing we like now we think, um how should P1 behave, all right? So I think this is, let me see, we're gonna figure this out, because I remember, like if we move P1 and P2 at the same time, this is answer where the match case. Imagine S1 is ors, and S2 is Or, alright, since they match, we move P1 and P2 because we don't need to process here. So I guess the answer for P1 is different. So, but we need to find it. All right, we we need to find the real logic. Let's move it there. Let's make it even smaller. Let's see. So our goal is to have this R in S1. So we are one of our option is inserting. So we need to insert this like a P2. All right, where let's say right side of pointer 1, and after we insert we get HRORSE. All right, this is original by the way. All right, let me type it, and also let me save this information that we gathered and saved over here. And about this information is that um like after inserting a character to the string 1, we are basically having a new string. All right, and in that new string it is hard to think about the position of P1, where the position, but the thing is P1 stays in the original one, like the P2 and P1 is in the original one. We are thinking we're taking these pointers on the original one. But also we should keep in mind the new version that we created, and based on that, like based on like thinking these two things, we're gonna find how to move these pointers. All right, but the idea here is S1 and S2, like you can see that S2 is on the original, like S2 pointer, I mean pointer 2 is on the S2 string. All right, and we easily understand um after we're done with the current character in S2, we just move it because we are done with it. But it is kind of a bit harder how to see, to guess how P1 should behave. All right, because let's say we add R, let's say we add R uh, after the age in string 1, then what actually? In the original array, P1 still points to age. Um, I guess we shouldn't move pointer 1. We shouldn't move pointer 1 because guys, um, we are done with we are not done with age. Age is still different. That's interesting. That's interesting. So we have what we want in S1. I mean, newly created S1. But like we are kind of done with it, but not fully. That's interesting. So this is the knowledge that I wanted to say. So we have saved this information there. Um, so guys, I think the answer for P1, and actually, guys, I really like started liking this translation trick. All right. Oh, Americana, I see your name over here. I really started liking the idea of translating the real world scenario to uh, code, because after inserting a character guys, we simply have a new string, but our pointers are on the original. Like on paper, when we add um, a character, we kinda lose the origin. Actually, we can create two tables, two different tables, so that even on paper we can see. Fascinating. Brainstorming is actually enjoy. Yeah, yeah. So the thing is, like, we basically don't need to have an animation, but really see, really capture the idea of pointers and where they are. These are original string, and we're done with S2 after inserting. So we move, guys, like we move it, like, because it has completed its job. But what should happen to pointer one? This shouldn't move, all right? I mean, because we're done with. Actually, it should. We should think maybe what happens if you move P1 versus we don't move it. If we move it, it means that, like, imagine, like take this as an example, right? Like we have it already. We have it already. Let's see. Like this is a good thinking to decide something. If you have two ways, try try each of them and see the consequence, see the result. Let's say we have matching case, because this is obvious. We should move both P1 and P2. All right? Like this means that if they match, we're done with it, and now our sub problem becomes here. So we basically done with the current problem. And in this case, like, I can see that after inserting R, we're done with P2, so we can move it forward. But if we move P1 2, all right, that would mean we're done with H2, and actually we aren't. So so P1, let's make P1 stay same, all right, guys? This is what I mean. And now in the original array, original strings, P1 points to here, and let me type it actually. Let's copy this part. Oh my gosh. I think it's gonna break. Come on. Alright. In the So we moved S2 to here, and P1 is still looking here. And the brand new version is S1 H R O R S E, and this is still, so we don't change the second one basically. So we have this one and this one. So like this is what insert gives us. It isn't something magical or complete. I mean, this isn't something complete, but one step closer to our answer. And this is the best thing that insert operation can do basically. All right. P2 over here, P1 over here. Now we have another case. H and O, again unmatching case. What should we do? We have three options. Alright, oh my gosh, guys. Maybe we are trying things a bit randomly, but not too randomly. Because if like the first choice was insert, but that choice can may or may not be the uh, may not be in the correct solution. All right, but it is obviously or it is 100% correct. uh, I mean its behavior was correct. We don't move our p1 but we will p2, so we are now one step closer to our solution. But maybe we should start with replacing. All right, maybe the in the real answer. All right, answer, let's suppose the answer is replace and then insert and then delete. All right, crazy idea, use vectors. What do you mean by vector, by the way? But like let's say the answer answer combination is replace, insert and delete. But what we have done is like applying insert. So this most probably this won't get us a correct solution. It may or it may not, we don't know. But so like if we think this from decision tree, guys, what I mean is that like in each level, like for each node we have three options, right? We have three options and we basically explore each of them, right? But imagine the answer is this one. Like let's say imagine uh, this path. So the remaining parts will be wrong, but also we may have another path too. All right, maybe this one, and then this one and this one. So these two may be the answers, but the remainings are wrong. So the first step we took was inserting, all right, which is this one. So this this is this dynamic programming idea is brilliant, guys, and recursion idea actually. We are exploring, we are setting some certain rules, all right, and then we leave the rest to recursion because it explores, and we set the rule like a rule that if you reach here, I mean we obviously should have a base case, certain base case. um let's say if you hit this let's say base case is, let's say, this one, all right. If you hit this one you are correct. Obviously it has hit here, and let's say if your value will hit, if your value hit this value, then your answer. So we literally say this as a base, set this as a base case, and Is this how autocorrect works? Yes, kinda. Yes, yes, exactly. Because I remember some data structure where like maybe try or something. There was a some sort of data structure, and mm, like these algorithms are used in where like in our daily life actually. So we basically set a base case, and we tell AI that like use this decision tree. All right, these are your options. Try each of them and explore. And when you hit the base case, save your choices and bring us them. So we basically do this. So so it doesn't matter if the first option that we try is wrong, or like I mean wrong or not. I mean it doesn't matter if the first choice is like it belongs to the answer or not, correct case or not. All right, but this is how we do it. All right, how we do it is move pointer 2 and leave pointer 1, because in my mind, um like each option should correct. Yes, so what I imagine is like imagine these are options, so each option should give me something so meaningful that I should feel happy. But actually, I don't have to feel that way. All right, and this is wrong, because imagine, guys, like we couldn't manage to move our P1. Like moving a pointer is good, but we couldn't move P1. But it is okay. All right, we are one step closer to answer. All right. Uh, all right. This is for insert case. How about delete? How about delete? Let's continue with from here, and here let's try delete operation. All right. This is fun, guys. This is fun. Amazing. So now we are. Let's suppose we are in this case. All right. We are in this case where again unmatching case, H and O. This is an unmatching case, and let's say we are gonna we are gonna apply delete. How do we do that? Because we have three options, we can like we will apply all of them, but let's see how would we do the delete operation. um Obviously, guys, the delete is easy, so we would delete the character, the unmatching character in this of where the pointer one points to, basically, because like this is the character we want, and this is unwanted character, and we operation is delayed. So basically we should delete it, and after deleting basically we're done with this character. So we move pointer one by one. Why? Because like after taking this operation, in the next phase the character we should compute or process should be this one. All right, like we basically simulate delete operation using pointers. Like this is real translation. Like so we move pointer one, but should we move pointer two, guys? You guess it, right? No, because still um, we don't insert or replace O in the S1. So we don't know, like the operation is delayed basically. We delayed it, but still turn S1 into S2. We need we need to make sure that we have this character in the correct order, in the correct place. here we are, here we are thinking like creating our delete operation, and we are done with at this P1 position basically, but we are not done with P2 position. All right, that's why we move P1, but P2 stays same. There has to be a way. If there is there is a way. Is this a quote or from somewhere? There has to be a way. If there is, well, there is a way. So this is how we simulate the late operation. All right. Now the replace operation. Now, um, now continue with the same example, and but now let's suppose P1 points to O. All right. But let's see. We're gonna see. So pointer now pointer one pointer one points to here, and pointer two points to O again. So we have a matching case. When for matching case guys, there is no option that we need to think or we need to care or about. All right, this is simple. This is basic if condition. We basically move pointer one and pointer two at the same time, because we don't need to process. We don't need to pick any option, because there are no options. That is an obvious step that we need to take, and this is it. And let's see. Let's continue from here. All right, in the next one. All right. Let's remove that. Let's delete pointer one. And now, guys, let's see. We like pointer one points to here, and pointer two points to here. And let's suppose we are gonna apply replace. All right, we can apply like the algorithm that we are designing will apply is gonna apply insert, delete, and replace for every case. All right, and when it reaches to end, we we select the successful path only. By the way, this is the idea of this dynamic programming question. All right, now we have like, let's suppose we want to apply replace. We have a obviously unmatching case, and let's say we pick the or algorithm pick the replace. So how would we do that, or and also what should we do that? So basically the thing we want is like we want s to be like this s here in s1. So since it's replace is powerful, we can directly like copy this one and paste over here, right? Because this is the definition of this operation. What will happen after this operation? What should happen after this operation? We are done with this character, because we literally replace its sibling in s1, and we put it s here. All right, so it means that we are done we are done with p2, so we can move it. And also we are done with p1 too, because we literally have the character that we need in this position. All right, in this very position, so like the position, because like, so that's why we move it. What if check it like two sum from left to right? Wait, no, synchronization would be pain. Yeah. So uh I don't see a way to solve this problem without um trying each choices. All right, let's say if we applied two sum, and still we need, like, we need to apply insert, delete and replace. So let's say we apply two sum. How would we do that? So imagine we have s1 and s2, s1 and s2, horse, and let's say horse. So you say two sum, but in two sum we had again p1 and p2, but where do they point to? Can you show me where p1 points to? Most probably you say here, right? And p1 points to here. But in two sum, our pointers were on the same array. Like imagine we have imagine we have an array 1, 2, 3, 4, 5, and pointer 1 points was pointing to here, and pointer to here, and they were going inward. So this is the idea of two sum. But here we have two different strings. Like our pointers are not in the same string, but on the same string, but on the different strings. All right. So how do you exactly plan to use two sum here, Americano? Like this is a brilliant question, by the way. This is mind opening. I like these um, thoughts. All right. But how what do you think? Like, how do you think you can use two sum here? All right. Can you say? Because for two sum to work, you should have a sorted array. Because here we know, like, we can predict the future. We can predict the future of this pointer. Because if we move p1 by 1, we know that we're gonna see a larger number, like a greater number. All right. But here we don't know what would happen, like after we move pointer one by one. P1 H, yes. uh, P2 points to O, yes. And E question mark move inside by one step. So now P1 points to O. uh, eh, this doesn't this doesn't, like, the idea was good, but again the thing is, I no no like that was brilliant. That was brilliant. I love those kind of questions. All right, but for like a two sum approach, we need a sorted array, and here we basically know the result of increasing the pointer one. We are sure that we're gonna see a greater number when we do this. So the logic, the foundational logic with two sum is knowing or predicting the future, being able to predict the future. But here, from the eyes of P1 and P2 here in this question, they don't see the future. Like we see, like as a human being, we can literally see, like, thank you for asking this question, American Back. Now you made me think this. Like we as a human, our eyes can see what comes next from age. But if we, like, maybe we can create an animation, all right? And the P1 and P2 pointers see, like, the only thing, like, they they see only, like, forget about this part, like they don't see it. Forget about this part, they don't see it. They don't know, like they don't have brain, all right? Like we have brain, we have billions of cells in our brain, right? But P1 and P2 are like a basic. I don't want to call them stupid, but they are foundation, they are core, they are atomic. So only thing they know is I have a character. Hey P2, I have a character. H. What's up? And P2 says, hey, what up, man? I have O. And now our algorithm will say, oh, like P1 has H, P2 has O. So now unmatching case. Now I have three options. Let's try this. All right. So this is it basically. But here, P1 knows the result of going forward. Let's say we sum P1 and P2 here, which is 6. And if the result is, let's say, like, I mean, if the goal is 5, after summing these up, P1 can say that, like, now the summation of me and P2 is higher. So now uh, I think I can, no, P2 is gonna say, P2 can say, I think I can go inward so that we can find smaller one. So this is the logic. This is predict. But here, there is no way we can predict because we don't know. Like P1 and P2 has no idea of future and has no idea of the next character. They just don't know. We break it down as a context, yeah. So that's why I'm stumped because I really think there's a quicker way to do this than and secure. Um, I think this is already better than Insecure. Let me ask AI to find the time complexity of this problem. I think it is better than Insecure because we don't um, actually actually when I look at this decision tree, mm, what is the complexity of this one? How do we calculate the time complexity of a DP problem? We have three options, obviously, uh, and it. Let's say you have three characters, but you have two strings. Let's take the longer one, the longest one, um, or it is about S1 being converted into S2. So we should um, take the length of S1, I think, and the number of like based on the length of this S1, how our like number of decisions change. For each character in the string one, we have three options. Yeah. Let me ask. This is something I didn't study. But it has something to do with depth of this tree. So let's ask this. In edit this tangent. In edit distance dynamic program question, we created like a decision tree where in each level, for each node, we make three choices: insert, delete, and replace. And now I want to calculate the time complexity of this. How do we exactly calculate the um, time complexity of this? Like, I drew the decision tree, but I can't tell the time complexity of this. What do you say? Let's see. Let's see if it is insecure or not. But I don't think it is insecure because we have a three structure, so it should be like a maybe I don't know log n. It like maybe log n, maybe three log n. Let's see. Total time. Great. The question your tree is exactly right picture to reason from. The trick to getting time complexity from any recursion tree is one formula. So this is the formula we need to know. Number of nodes in the tree times work done per node. So work done per node is three. I mean three operation, right? And the number of no. Let's see. This is not the operation. The operations are already represented in the tree. Number of nodes. So how do we calculate the number of nodes? um, we have depth of two, uh, like 2 to n, right? Like level. Do we say level 0 and level 1 and level 2, or level 1, 2, 3? Let's see. So you need two things. How many nodes? How do we calculate the number of nodes, Americano? Work per node. At each node, you do like this comparison operation, yes, and take minimum. All right, so count nodes, branching factor, depth. A roughly full tree has this number of nodes, where B branching factor and D depth. Branching factor here is 3 in our case because we have 3 options, and depth. This is the part people miss. Depth, longest path from root to leaf, root to a leaf. Ask what is the slowest path that can shrink. All right. So our time complexity is Americano. I think this one, not n square. Nodes is itself plus child, I think. The punchline, why DP rescues it? Here's the key observation, your tree heights. How many distinct nodes are there? Every node is fully identified. Alright, so since DP is an optimization, uh, like there can be some same sub problems that we may need to solve. So if we store those sub problems, we improve, we optimize our solution very much, basically. So this is the beauty of DP. But now I'm trying to understand it. Is it better than NSQR? Most probably yes, but I want to make sure. And what is time complexity? So naive recursion is this, like distinct repeated nodes, exponential. Memoizide is, so it is not n square, but kinda n square. Like if m is equal to n, it's n square. It's worse than no, like the naive recursion. Maybe naive recursion. It's not quadratic. It's exponential. Oh my gosh. So why do we use DP after all? Memoization simply says the first time I solve. Yeah. So we know I know it. The reusable method for any recursion tree. For edit distance, B is 3. Naive. So the optimized, like I mean, Mimosite version of DP is this Mimosite, and the unoptimized version is definitely worse. Uh, let me take a screenshot of your message and put it here, and also add that learn how to calculate the time complexity of this problem. Like we should know, but I don't want to spend time understanding this, but go. So now the beauty of this question, so let me, the beauty of this question is translating real world to digital world using P1 and P2. That's nice. Let's color this and continue. Uh, count good notes. All right. So like yesterday, um, I have like we have studied pre-order traversal. All right, and I figured I am quite familiar with post-order traversal, but I'm not good at pre-order as much as I am good at post-order. So um, and also while I am at the seaside yesterday, I thought that what did I think of? I thought that like I love the idea of post order like this, alright. So let's say Funk left. We expect an answer from left child. And let's say Funk right. So what this means is like imagine we have a tree, alright, and there can be any number of child nodes, alright. When we call Funk left, and when they return, when it returns actually, when it returns, you can imagine that our left subtree is solved. So this is the beauty of recursion. So we don't know how yet, but you imagine that it is solved. And after this function return, your right subtree is completed too. Now you can have, or like most of the time you have the return value, and now your job is to process these and add some base cases basically. So this is about post order. But the thing about pre-order is like in post order, like Americano guys, everyone listen to this very carefully. When we are applying post order reversal, we are like we imagine, like you can imagine yourself as a parent, all right? So x and y are symmetric. Like this problem can be about symmetry, like inverting any problem, but the thing I'm showing is generic. It is not about symmetry. But there is a tree problem where it is like it asks, is these two trees symmetrical or not? So you can imagine yourself as a parent in post order, but in pre order, you should imagine yourself as a child. Imagine yourself as a child, this left child, all right? And you have your children too. We don't know how many, all right? And we don't care about it basically. Our focus is here. We are child. Imagine now, instead of typing this, now we type like we are function, and we are now getting an argument from our parent, guys, from our parent. uh, we suppose that our parent shared this knowledge, argument one knowledge with us. All right. Um, there was another thing too, but this is the idea of pre-order, and we basically think about what that knowledge would be and how can I process this knowledge. So here, imagine we add uh, 10 to this argument, all right, and we let's call it x, all right, and we now share this information with our children like this. So this is the way how I represent or how I draw a pre-order traversal. In post-order traversal, imagine you call your left, your right, or any number of your children, but in trees you have two. You call your left, you call your right, all right, and when this function return, then you can assume we are done with, like we solved our left subtree completely. And we call, when we call, like after this line, is executed, you can assume that this subproblem is done. So like everything, imagine this is a huge subtree, but it doesn't matter. Like, of course, the time takes for completing this tree may increase with the number of nodes that we have in this subtree, but it doesn't matter for us to design a recursive solution. Of course, it matters for uh, real, algorithm to complete. All right, let me skip the um, Pomodoro. Yeah, of course, it matters for CPU time, it matters for real time, but it doesn't matter for us while we are designing the algorithm. This is the important thing. So when this line executed and finished, you can assume that you have now solved right subtree, and the right subtree is done. And let's say they return some values. Now, as a root, because we are root, so basically we are here, right? We are here inside. Now you can process and return. It is up to you. So now the puzzle you need to solve now is the what about it is about to it is about what the question asks. Let's say if it's asked summation, you sum them up. If it asking you to invert, you basically invert. Whereas in pre-order, now you see, like, you are looking, imagine yourself as a child. You are looking at the world from a child's perspective. All right, and there is an information that comes to you, that is handed to you. It is argument, and the way for your parent to hand you this information is argument. And the way, like, for your I mean for your children to hand you an information is return, basically return. But here the way is using argument. Your parent used its argument to share an information with you, and you are processing that information, and now you are sharing that information with your children using, again, argument. um so bottom up, but yes, bottom up, yeah. Post order, top down period. Actually, bottom up and top down, like, a different terms. But if you mean, I mean, like a going up, we use post order, while going down we use pre-order, because like, we use bottom up and top down in different contexts. All right, these concepts are used in dynamic programming, and they mean a little bit different, I think. But for the direction, it is up when post order, it is down when pre-order. Yes, correct, American. So this is it. Now, for our count good notes, so let me open the question. So in this question, guys, the beauty of this question is that we're gonna apply post order and pre-order at the same time, because there are some questions where you can solve using only post order, where you can solve it only using only pre-order. But here we need to use pre-order and post order at the same time. Let's see how we do it. So the question asks, given a binary tree root, so return the number of good nodes, and the definition of good node is, a node is a good node if it's it is bigger than all of its ancestors, guys. So imagine 3, 4, and path, 3, 4, and 5 path. Ancestor of 5 is smaller than it, and ancestor of 4 is smaller than itself. So this is these are good nodes, but one is not good because its ancestor is bigger than itself. It should be small. Oh, this is top down pre-order. This is top down. Like this, in this question we're gonna like actually, yes, you guessed it right. So while going down, we will share an information. So just say check if is self larger than ancestor, but the current mask is passed down. Oh my gosh, you are going fast. We should have an information of like some as as we do in greedy problems. We should have a variable which is smart variable that holds current max. Yes, I think I got your idea, and yes, we are gonna apply this. Current max will should be passed down. Yes, like we set current max to 3 here, and we should share this 3 with its children. All right, let's draw it. You got it. You got it, Americano. And let's open that one. We set current max as 3, and now we are applying pre-order and share this knowledge via parameter via parameter and give it to our child, child, right child. All right. So we basically like imagine imagine our function, recursive function, as this one. All right. Um, this is zone. All right, where we do our pre-order stuff, and like before the recursive call, and this is the recursive call, and here we calculate our current max. All right, which is the value of current node. All right, equals val, and we should, I mean, not val, but since it is current max, it should be um, like math max. Like we need to use math max. Compare it with current max and value. All right, we should have something like that. We shouldn't update each time. I mean, um, we shouldn't set the current max with value immediately, but instead we should hold the max. Like, or what should we do, Americano? Should we compare only with its immediate, or like we have a smart variable like a greedy problems? It's like a running sum. I mean, like something like running sum. All right, and share it. Compare it with max only. Yes, yes. Like this seems quite logical, but it is not crystal uh, crystal clear to me. But most probably this one. Let read the let's read the question again, guys. But where is the definition of good? Hmm. We don't have the definition of good. Even our is named good. A node X in the tree is named good if in the path from root to X, guys. So, like, look at, guys, look at it, from root to X. So we should have a variable, an information, all right, that is a history, basically history. So to hold the history, we need to have something like a running sum and share this knowledge with our children. Then just check when it has no more child. Then just check. Like it should be base case. Like what we are saying is base case. I'm leaving base case at the end. So this is our history, guys. History. All right. Actually, we shouldn't call it maybe current max, but um oh my gosh, I just forgot what is written there. From root to x. So the current node should be greater than every one of them. So we should have, like, imagine, guys, forget about this question, but think this, take this as an example. Imagine we have, oh my gosh, we have a linked list. All right, imagine we have a linked list, and let's say we have numbers here. Why in the output did it say output 4 not 5? Because there are four number of good nodes. This node, this, like this three, 4 and 5, like all of them are good nodes. Like take this 3 as an example. Its parent is smaller than, oh, hold on a second. That's a good question. Uh, its parent is smaller, but for one, so yes, yes. One is not good, but three is good because it is same or greater than every node from root to itself. Oh, you count the nodes, though you outputted the value. Uh, yeah, so you don't return the node itself, but you return the number of good nodes, basically. You need this detection system to detect every good node, and you return the total number. So imagine, guys, you have a linked list, all right? And let's say we need to detect every good node in this linked list. How would we do that? So just an if statement and increment. Yes, yes, exactly, exactly. We need a global, um, uh, like a total variable, and each time we find a good node, we are gonna basically uh, we are gonna basically increase it. Yes, outside of our recursive function, we're gonna have a global variable to hold the counts, basically. Yes, count plus plus. Yes, exactly. So let me. Oh. So now my question, guys, here is: imagine we have an linked list, all right, and our goal is to detect every good node in this linked list. 5 is a good node because it is bigger, and 7 is good node because it is both bigger than its immediate parent and like all the nodes from head to this node. How does it know it's a child of who, and how does it know how many child it has to pass down? It's like wonderful Americano, wonderful question. So like you ask that, how does it know how many child it has to pass down? Amazing, bro. But the thing is, it doesn't know. This is the beauty of recursion. All right, it doesn't know. Like recursion is brilliant and amazing approach where you don't need to care about every possible scenario. You basically set the essentials and let the recursive function handle it. It doesn't know. Like forget about numbers, but focus on the logic part. All right. And your second question, how does it know it's a child of who? So basically, like this is about recursion. So Um, so let's look at it. So like if we want to apply pre-order, in this question we're gonna have to, you imagine yourself as a child, all right? As I said, you are imagining yourself as a child and your parent passing an argument to you, all right? So like I now like writing the stack frame of this node, all right? Pay attention to that. So we are this one, and there is an argument given to us by our parent, all right? And now we can just use this argument, do whatever we want with this. Let's say adding 10, and we can call now recursive our recursive call with using this one. This is how. And the brilliant thing about this question is the argument that we are getting is already holding a history. All right. That's why I asked this linked question. But mm, I think like I can prepare some notes on recursion. You need to internalize the idea of recursion very well to understand this, because the question you ask is about still like a thinking from it, thinking iteratively, not recursively. We don't care about how many nodes there are, like the structure. No, we don't care about any. All right, we don't care about it any. So this question is combination of greedy, running some idea, plus pre-order, plus post-order. All right, I'll brainstorm a bit. So yeah, it's like I really want to prepare a short video on recursion, and I also plan to share the questions that I'm gonna study in the stream prior to the stream, so that you guys can practice, so that our streams are gonna be more effective than ever, basically. All right, like a real curriculum or something, because this is the best way to learn. If you practice before the stream, during the stream it will be better. If you, and also you can write your questions and we prior, so we can study them. So now like I want to focus on the greedy part of this question. um let's suppose this is not 7, all right, but 1, all right. So we, why I can't just type here anyway. So we call this linked list using the head, which is 2, all right guys. All right, so we just started. Now what do we do? um since it is pre-order, we should um look at from, look from eyes of 5, all right. So let me draw the stack frame of 5, basically. In 5, our parameter is 5, all right, and an argument that is given to us, but we don't know about it, but we're gonna understand it, find it. So this is stack frame of 5, the value is 5, and the argument should be like a some max value or something, which is equal to 2, all right. We should have 2 here, because it is the maximum in the prior to r, so it is 2, all right. Now we are in pre-order, so here in zone 1 here, um, we're gonna check if our value is bigger or greater than our parent's value. All right, this is parent value, and parent value is history. Like, this is important, guys. We don't give the immediate value of our parent, but instead an argument that holds the whole history. So this is the brilliant part in this question. So all right, this is for 5, and let's look at how it's work actually. Like, let me draw a case where we can see this history very well. All right, let me copy this part, because in the next example, we're gonna draw the stack frame of 1, and 5 is gonna give 5 as an argument, as a history. But still it will seem like we are getting the value of 5 and sharing it with 1, but we don't actually. We share the whole history. This is the brilliant, this is the amazing part about this question. So to show that case, guys, um like, it would be enough if we change the order of these two actually. All right, let's imagine, let's suppose we have 5 over here and 2 over there. All right, let's see, we start with 5, and the max value is 5, and here it is, like, now, like, let's look at, like, it is 2, it is smaller than its parent, and max is still 5, and we don't count this as good. And when we call, like, when we make this call, the place we make this call is in stack frame of 2, all right, and we make this call 1, and we share, like, we don't share the value of 2, but instead 5, because this is the value given us. So that means, guys, when we find a bad node, not good node, bad node, we should share the argument we got from parent and share it with our children. But when it is good node, all right, let's look at back. When it is good node, like 2, 5, all right, uh, and maybe it is 7, right? Let's make it 7. Um, but it doesn't important. It isn't important. So when 5 is good, all right, we update our max basically, and um, share this. This is kind of like, this look complicated, but I totally understand. So there are two cases, guys. Let me summarize. One, um, we are bad. We are bad. When we are bad, let me draw. So imagine this is our previous version, and we are bad, which is 4, and it doesn't matter what we have as a child. We are 4, all right, and our parent, let's say, shared 5, and we are uh, smaller than it. So, like, our stack frame is, like, we are 4, all right, and we have an argument which is 5, let's say, let's suppose this is the max value, this is the history, and let's make it 5. So now what should we do? We should share this max value with our child, all right. So we shared argument 1 exactly, and call it actually. Yes, so this is it. This is bad. When it is good, all right, let's suppose the node is 1, and then 2, and then 3. This is a good scenario, and we are 2, all right. Now I'm drawing the stack frame of 2, all right. 2 is called like this one, argument 1 equals 1, And what should we do? We should here now update the maximum value because now we are bigger than our parent. We are greater than our parent. Now we should uh, we should get argument one to ourselves, and then when we like the time we call our child, again we need to share that argument. Argument one equals to two. All right. So this is good case. The only difference is basically updating the argument. All right. In good case, we update and then call our children. In bad case, um, we share the argument directly. So we don't update the argument basically. So this is it, guys. This is the pre-order part. This is the pre-order part of our question. Let's see what we have for post-order part. Um, so we have shown this pre-order approach on linked list. Let's open our original question. Um, yeah, so we have a greedy running sum, which is max. I think we are done, but I don't see. Actually, guys, I was gonna say I don't see a post order, but post order will be about this number. All right, let's see. I think. Let's see. We have. Let's suppose we have a tree. Yeah, and we call pre-order yes, and we share the knowledge max along the way, and we updated it when we find a bigger node. All right, and we don't update it when we find a bad node basically. Now guys, we can design our recursive function along with count will be global. All right, and we will update it in our recursive code. So case one is, let's type bad case. When we find a smaller one, we just share the max immediately and we call. All right, so when bad case, but how do we understand it is bad case? So there is an argument coming from our parent and us. So we basically, if our value is smaller, all right, than our ancestor, our parents' value, then it is a bad case. Then what we should do is like call, um, obviously we don't stop and we don't just go to the corner and cry, all right? We continue no matter what, but we just more careful about the variables that we use basically. um, if it's a bad case, we don't obviously increase the count, global count. And also while we are calling for our children, but it is a tree, so we should make a like a we should make a left call obviously with the same argument, left arc one and right. So we share the same historical knowledge. And this is bad case. When good case, so let me move this part. Good case scenario. The number is increasing order, so good case. If the node's value, if the node's value is greater than our parent's value, guys, this is a good case. Now we should update argument one with our value because we are bigger than it. And when we call our children, guys, func left, we should use that updated argument. All right, func right. Yes. So, and also we should increase the count. So this is it. But still, I don't see where we apply. Um, so we update the count. I don't see the post order place still, because like I don't feel we've done with the return value of these. But let's see. But I remember in the question we had something like a note saying that we should use post order and pre-order at the same time, but all thing like I did here is um, about pre-order basically. Uh, hmm, that's interesting, guys. But but the thing is, because as Americano said, we are using a global um, count value basically. All right. But here, all right. So let me make this problem also, because we are using global. But what if we weren't using global value to count the good notes? So let's remove that part, and let's suppose our left call and right call return the number of good, so the number of good notes uh, that they include. All right, so left returns number of good notes, right returns number of good notes. All right, um, and if we are good too, I mean if we are good too, I would say we would sum them up and add one and return that. So that would be my answer. But if we are in bad case, then we would only return the summation of these without adding one. So let's see if it is the answer. Let's see if it's an answer. I think yes. I think yes. It is a little bit more elegant way of what I have written, but it is the same. If it's a bad case, we don't increase. Like we don't like we only return what our children gives us and summation of these. In good case, since we are a good node too, like since we are a good node too, like imagine this is x, this is y, and we are good to go. Let me draw a smiling face. Since we are a good two, oh my gosh, this doesn't look cute at all. Since we are good node two, we return us ourselves and answers coming from our children. Amazing. Now I understand it. Actually, I already understood it, but I said like I don't see why this question is like a post order two, because we applied global counter outside of our recursive call where we store the counter. Both are okay, but if you want to practice post order, you can use this approach basically. So we have reviewed this problem too. All right. Now I think we can we can continue with Java because I feel a little bit tired. Let's see. Oh, so it is not 3 hours yet. So let's continue until 3 hours because we love taking a break at hour three in our first session. Let's open our all languages, and this is the question for calculating the time complexity of that DP, like a edit distances problem. I think I will look it up later. And what is it? So yes, so now I think I can make it full screen. It seems nice. Now, where were we, guys? Now, I think I can update the topic now. Topic is developing a banking system in Java Spring Boot. In Java, using Spring Boot frame, framework. All right. So handle not found first and show me one notch before you start. Decide the body shape. So where were we again? Oh, I guess we were about to add an exception to one of our endpoint, I think. Let's see, where were we? Uh, Java account and global exception handler. So like this is a notation obviously. Let's control the advice. I think this makes the class below it a special class where it allows us to type our custom exceptions, I suppose. And we have studied this type, like generic type, right? But let me ask AI to answer it once more. Before starting, um, check our previous notes. We have studied this generic type. Here, the handle not found method returns um, like a response entity. But what's up with this generic type? I mean, like, should I understand this as a like a list of something, like, because while initializing a list we are using something like that. um like, can you find those notes actually? I forgot where we were, like, we saved. I think in generics folder. Yes, I think here. Copy the relative path and find it. And could you please do a quick recap about generics, and then we can continue. Let's make a quick recap about generics and understand this type before we start. While it explains, uh, while it's explaining this stuff, we can read what it what it has written. Starts start with. Can I, like, this is too bright? I guess it is good, right? All right. Start with handle not found method. So this is our method, and it says that the confident one built repository entity carrying status 401 and the exceptions message as the body. So this, we have what we need to do here actually. Return a response entity with status 401 and a body message. Like, we obviously need to create a response entity, but I don't know how. See, let's see. Um, so for generic question, a type parameter. So list string, a list whose elements are string. Yes. The thing in the angle brackets. Yes, the term is angle bracket. Is the element type. So we have this. Yes, this question mark extends this. This is producer, and this tells us that classes. Like, imagine a class. Like, a dead class is this, and this is the child of T. So we accept T and children of T. So we are going down. Here we expect, I mean, we welcome classes, like same, like it can be T, same as T, and its parents, it is up. So producer, you read T out. Um, like we have string like a static method join and iterable. Yes, iterable question mark extends car sequence. Yes. So like basically we welcome um, classes that children that extends basically extends that class. That means subtypes of this. And this is consumer. You write T like list sort like a class E and its parents. Like now that we understood how they work, the next thing is to understand like which one to use when. In which case we should use producer. In which cases we should use consumer. At a wildcard, Java invents a fresh unknown type. What is that? And only allows. Maybe I can just make it a little bit bigger. Right, guys? Um. All right, I think. So the one your response entity uses the bear. Bear. This one. So here's a key correction to your instinct. You ask, should I read this as a list of something? No, response entity is not a collection. T here is a type of the body it carries. Body. So response entity wraps a string. That's interesting. A string body. Response entity account wraps an account body. Same machinery as list T, one type slot, but slot means body type, not element type. So there's a distinction, like there is a there are these terms basically, body type and element type. So maybe we should just open this quick, paste it over here, apply OCR, and do we have something for Spring Boot? Yes, Spring Boot, and it's actually about Java too. So Java, what do we have here exactly? Can I scroll down? Yes. Um, language Java concept cast. It is not cast, but generics. What do we have? So we already have generics. All right. What else we have? We don't have anything. So all right. So we have like a body type and element type. Like I love these terms. Body type and versus element type. All right. So all right. So and bear question mark no extends no support is the unbounded wildcard. The third member of the family your nodes didn't drill yet. Um. So body is definitely a string. Body is some type. I'm not committing to which. All right. So guys, this is for library authors telling us that you can put anything basically. So if one day you're gonna be an author of a language, then you need to know this. All right. It reads, I return a response entity, but the body type varies and the color shouldn't depend on it. Why it is here? Handle not found might return a string message. Might return a string message. Handle insufficient founds might return a record. Different body types. So I guess now that the question is, thank you for this amazing explanation, but the thing I need to understand first is what is body type and element type basically. You need to explain these first. My language will be named verbose, which is just programming language using plain English. All right. Running multiple cloud sessions. Run. So there's a new comment, I think, guys. Fair. I used both terms like you would know them. They are the same mechanism. I mean, I can maybe like take this one. So they are the same mechanism, wearing two different jobs. All right. Um. So list T. So guys, we do this while creating or initializing a list basically. The slot is the element type. So we basically like yes, we are when we are initializing an array list, guys, we literally indicate the type that we can put in this list. You put strings in, and we get like we take strings out. All right. A list holds many of T. So T, what kind of thing is inside the box? Repeat it. So list string, a box of many strings. That's an element type. The type of each element in the collection. This is only meaning you've seen so far, which is exactly why your instinct said list of something. Yes, yes. So this is the only version of or only usage of T that I seen. Now the element type. Now the body type. So response entity, the slot is the body type here. All right. Uh, Body type. So again, we are creating. All right. So we have this one response entity. Okay, hello. So the body is one string, not a list of strings. One string. But what is body exactly? Now, now the question is what is body? Response entity is one HTTP response, like response entity, like I mean this one is one HTTP response, a status line, 200, 401, some headers, and one payload. That payload is called body, guys. The payload is called the body. So there is T. So here T. What type is the single payload I'm carrying? Oh, so one response whose body is a string. So response account, one response whose body is an account type. So the point T is repeated element type, many T's inside. T appears once, body type. For example, optional string T appears once, the value it may hold, and it may not. And comparator string T is what it compares. So, alright, so maybe guys, I can I can take a screenshot, guys. So base so now maybe we should go understand what is body. So it is not about yes, it's about generics. Yes, so same T syntax every time. The word element body value is not Java keyword. It's just the name the library author gives the slot based on its role. The compiler treats them identically. Only the docs and your mental model differ. So response entity, one response carrying a body of some type. I'm not I'm not pinning down. Not a list, just one payload. So the thing is, like we are using term body here as a payload body, but like what is the other usages of this T actually? I wanna understand because like you showed like a optional string, I guess. You also said the value it may hold. So the meaning changes. So for response entity, since response entity is a HTTP response, the string represents its body. But in optional string, we say the value it may hold. And for comparator string, he is what we compare. So the meaning of T, I mean the role, the field that T represents is also changing, right? So so for response entity, it is body. But how do we exactly decide which field we are gonna use? All right, maybe it is about us looking at the implementation of that class. What do you say? So like it said, um, like a body type and element type, but that body type can have like a different example cases basically. I think I didn't paste. Let me copy and paste again. So body type and not type body type element. So element, like I can like we can understand this as a from list. T means element like item type, element type or item type. But we have other usage of T, which is body type, and here body type can vary too, uh, depending of the class we use basically. So exactly right. You read the class to see what it does with T. Yes, let me confirm it by showing you the actual interns, because your hypothesis is the whole answer. T is just a placeholder. Its role is whatever field parameter return the class plugs it into. All right, so the meaning of that T is basically these guys. So maybe we can just paste it over here, and it would be great if we assign some colors too. So in array list, uh, let's look at it, guys, how T is used. Here T is used inside the method as a like a type of item. All right, and in response entity, the T is used. Oh my gosh, now it is crystal clear, guys. It is crystal clear, guys. Look at it, guys, look at it. Like in array list, like the T is something like a used for add methods argument type. Here in response entity, T is used for the type of the body. Like body, but you may ask, what is body? Body is a literally field of the class. In optional, it's for value, like it's another field of the class. In comparator, it is used. Oh my gosh, guys, now I see. Like this is a wonderful feeling, guys. This is a wonderful feeling. So it is much easier than I thought. It is basically anything. It may anything. It may mean anything. Um, like in array list, like just open the class, guys. Like if you want to understand what does T stand for, just open the class, all right, array list, and see where the T is used. All right, T is used here. T is used here in an argument type, as an argument type for a method. Here for a type of the field. Here again field. Here again argument type. This is it, guys. Like but like forget about this body type and element type. All right, just open the class and see it yourself, and you'll immediately understand the the meaning of it. Oh my gosh, I feel so. So guys, um, it is not. It is still not 3 hours, so we need to push ourselves, guys. What do you think, guys? Like, are we going fast or slow? Um, like, but finally, I figured the meaning of this T out. I'm happy. I'm on my third Gemini right now. Already consumed all the code from other. Yeah, like they cost a lot, right? But you understand the idea of T, right? Americano in Java. Like we like most probably we have this concept in other languages too. T may mean anything basically. You can put it for a type of an attribute for a class. You can put a type of the um, parameter type, argument type, anything at all. Now I see. So where T appears in the source in a field that let's yeah, I get the idea for generics, but deep diving on my own right. Or good luck with good luck to you with that. Oh my gosh, we are famous with our deep divings. So only in method parameters never stored. Um, yeah, it produce. All right, so we get it. Now I think, guys, we can like quick proof for you. Yes, yes, yes. So I think all right. Thank you for this brilliant explanation. I think now we can continue typing this thing, this handle not found except exception. Can you give us a hint? Um, Let me click on this entity and let's look at where we have this T, guys. Now we are trying to catch the T. Oh my gosh, where is that T, guys? Actually, yes. Like we have it in body, I think. Let's find in HTTP. So it is used in many places. Like let's look at like in if it even in its constructor, it gets HTTP status code and a body, and the type of that body is this one. All right. Extension of HTTP entity that adds an HTTP status code. HTTP. So this is where so this type can be anything, but it should be same as this one. But where exactly we uh, give like insert this T while generating, or maybe most probably we don't do this and Spring Boot handles it. Before answering your question, could you please tell us where do we exactly add this T here? I mean, while calling, or does the Spring Boot framework handle this us for you, for us, handle this for us? Um, because when I open response entity, I see T here, but like, where is the start point of this? Like, I know like the rule that this implies is that use the same type in a, let's say, constructor, like in every place that T is placed, basically, right? I totally get it, but where do we exactly decide the which type of t we are using. So press enter. So great question. You opened the actual jar and you are, yes, staring, yes, tea decoration, wondering who fills it. Yes, so this is what I wonder. Who fills it? Here's the answer. You fill it. You do it. But how and where and when? At the moment you build the object. Building the object or initializing the object? What do you mean? And usually the compiler infers it, so you don't even type it. Oh my gosh. There are two places T can get decided. So imagine we are initializing like this one, like explicitly and inferred. The compiler reads your argument, the normal case. Oh, this is a string, so T is string. Response status body. So what do we have? Like, do we have something like status? Yes. Status. Do we have HTTP status? So we should have body. But what is the connection between like this being string and we transfer this string into here response entities type, uh generic type, I mean. How do they, like, how does it go there? When you call like this one, you hand it a string. Look at the method signature inside that jar. It's roughly, so I think guys we have this method. Let's see. We don't. Let's see what we have with body. Let's see. Like, not this body, not this body. Like, this body belongs to status, and status is not response entity type. Body builder, another command body, another argument body, but like we are looking for function body, so maybe we should just use this one. All right, now out of 9, I think yes. So now here we have body method, headers builder. So we build and we return body. So where is this body? I think this one. So it is override, and it takes body t. Yes, so we see t over here, but hmm. So guys, I think like so let me explain. So thank you for the explanation, but like I thought that to decide this to decide what this t is, I thought that we should like give this t while we are instantiating, like while we are using its constructor or something, all right? But I guess um, like even using this t in any of the methods um, or properties, that is like in any properties of arguments of the response entity, if we use t, then our compiler automatically understands and put that type, let's say string, in every places. So if you need to call, let's say, another method that, let's say, returns a type t, after you call this body method, all right, if you call that another method, that will return a string too, right? So this is uh, this is how it works. And I had a misconception and I had a bias, right? So we don't need to initialize um, the response entity class with that type first. Or what do you think? What is the order here? This is what I'm asking. Let's see. And what did it say? Infer. So like we are now like using you are we are using now inferred. Like the thing we have put here as the type of string. So that response entity now returns, I mean, the type of this response entity is now string too. Because in this body function, as you can see, we have t here, and when we go back up and find the constructor, I mean, the class definition, you can see this. And if you go to here, the return type is this one basically. So, and our goal was returning a response entity. And also, how should I say, like, the type of response entity is string, or the generic part of response entity class is t, like, I mean string, like, uh, I mean, what is the difference between response entity and this response entity, and how do we call this part exactly? Now I'm gonna ask this one. Let's first read. Um, let's first read what AI answered first. You got it, and your correction of your own bias is right. Let me sharpen the order because there is real sub little hiding in it. There are actually two different kinds of T, and which one you are looking at decides the order. Kind A, T belongs to the instance, a field type. So once an object's T is bound, every method on that instance speaks that T. This is your, I didn't get it. Let's continue. So T locked to string for this um so T belongs to the instance. So if we do like that, T is bound to this instance. All right, I get it. Now return string because we gave string over here. Here T was decided when the object was built and stays fixed. Your instinct bind it first, then all methods agree describes this case perfectly. Kind B, T belongs to the single method call, single factory, alright. As Americano would know, factory means static. This is the twist in your life, in your not life, but file. Um, so this is the answer. So response entity status and body are generic methods. Each call binds T fresh on the spot from its argument. There is no instance yet to carry T. The order is returns a bodybuilder, T still open, string enters here. Yes, so it's be like string enters here with this argument. T string now. T is decided at this call, not earlier. Yes, but how do we transfer this knowledge to response entity itself? This is what I'm asking. So binding happens at body the moment a concrete value lands in T-shaped slot, not an imaginary initialize this class first step. There is no separate initialization. The factory chain is the construction, and T snaps into place when the body argument arrives. The order stated cleanly. Guys, let me use my eye drop because I mean, alright, now much better. The order stated cleanly. Um, so your final understanding is correct? No, you don't initialize with type first. You let the value flow in, the compiler reads it, T locks, done. The only nuance is which call does the locking for the builder chain in front of you. So thank you for the amazing explanation. So body triggers this chain and assigns T, but the thing I'm asking is, um, does response entity get that information back to itself too? Or, I mean, can you give an example showing, um, like, after body triggers the chain, next time we use response entity or response entity's properties or add any other method, it dictates or I mean it limits what field, what type of value we can use. Like I wanna see that. Let's see, guys. And also let me drink a bit water. Let's see. Yes, that's the whole payoff. Body locks T. All right. The returned object remembers it. Return object, it says. But prior to that, it said it is factory and static. Let's see. And from then on, T constrains. Yes, this is the word I was looking for. Const constrains everything you do with that object. With that object. That's amazing. That's amazing. Here's the proof line by line. Body receives a string. Uh, yes, body receives a string. The return object is response and the string. Oh, like I loved this example, guys. Let's just paste it at OCR and generics. Uh, Now from here on, the object R carries T as string. Now it dictates. Now if you use getBody, it will return integer. And if you use it like this one, won't compile. Alright. And this is not gonna compile too. So the flow is body binds T string, produces this one. That objects get body now. Alright. So the information does flow back into the does flow back to the object. Flow back into the object. Does. It does. So T isn't one time thing that evaporates after body. It becomes a permanent property of the resulting object. The compiler stamps onto it and enforces that stamp everywhere downstream. The tie back to your file. This is exactly why your method signature is and not this one. Because guys, you can put different type of messages here. Maybe like a HTTP type, maybe string type, maybe let's suppose integer type. And based on that, it gets It returns that that kind of response entity. If handles sufficient funds later returns error record. Instead, both still fit this one. So that's the reason wildcard is on the signature. The object always has a concrete T, mhm, but the method refuses to promise which one. So different handles. Alright. So now using T propagate forward and constraint, type the return. I type the return with so guys, now it is time. Um what should we do, guys? Like, should we type this one? But like I was gonna ask, where does this come from? But this is a class and this is a static method of it. So um and where we are again, we are in handle not found. So we use http status not found. All right, and body x get message. So as we give this as, it, as a string to this body, the return type becomes response entity string. So like this is a this is a brilliant approach, guys. So like it is it is quite dynamic. We don't what happened, American? So like it is amazingly dynamic. So based on the type of the argument you pass, your return type changes it. So this is just brilliant. You don't need to type different body methods. You don't need to type different response entity classes. All right. You just type one and it can return anything. So basically you can dictate some of rules and you can open or release other repetitive uh, boilerplate parts at the same time, which is amazing. Um, but I don't know what to return. So save this file and can I do this? Judge it. Let's see. All right. One back and it's the imported one. All right. Line 29 builds right object, then it throws it away. Yes. So guys, so it returns an object. This factory class returns an object, and the all right. So like return type of it is string, I guess, right? I should type this because I know this is a string. Um, and let's call it R. All right, and return that R. How about it? Judge it again. Judge it again. So handle not found is correct now. And notice what you did. You wrote, yes, I deliberately, explicitly type this string explicitly that compiles because produce, yes, and response at this string slots cleanly into the this part, this return. You just lived the whole T binding lesson. One line green. All right. That's amazing, guys. Now I totally get it because prior to that, like I was avoiding reading. I was even avoiding reading this part actually. And now for this part, we should like handle insufficient funds. What should we do? Return a for XX response entity with the exception message. with the exception message. Uh, so again, I think we should use um, factory method again, but with not HTTP status not found, but maybe something else. Let's see. Which for XX status, yes, the exception means you ask to withdraw more than you have. That's a valid, well-formed request that conflicts with the current state. So the so 400 bet request or 409 conflict or 422 unprocessable entity are all defensible. Pick one and have a reason. Um, I don't want to apply bad request because bad request is some broad, but conflict would be okay. But how would I do that exactly? Maybe I just should copy this part and paste it over here. Um, and then instead of not found, maybe we should open HTTP status and find some codes. I think we have a lot of them. For our case, which is insufficient found, I guess it was 409. So let's click on it. 409. So conflict. So what do we need? I think so. It's conflict. I suppose. So not found, but conflict maybe. And we should return this R. So basic, imagine guys, we are typing okay this function while typing this function. By the way, couldn't we just type like this one? Now this is gonna be my next question. Judge it. And also let me type this one and let me ask. And also couldn't we just type this method like this? I really want I I really wonder this if we can do this alright. Because the thing that type of the thing that we return is this basically, but here it uses this one. So there should be some sort of reason behind this. Alright. Let's press enter and let AI to judge it again. Let's see. Both handlers are correct. Like a conflict is solid pick. The record is well formatted, but conflicts with the current state of the resource. Yes. Now your question. And the answer is yes, you absolutely could for this exact code. Would compile and behave identically because both and yes. Yes. Spring serializes it the same way, nothing breaks. So why did you scaffold to use why did the scaffold use this question? Three reasons. And notice none of them are none of them are it is required. Future proofing the body type. The day you upgrade the body from bare string to a record error response like this one, a string signature forces you to edit the signature too. So they already accept it. Zero signature Karn or Chorn, I don't know. The handler is the kind of code whose body type that. So guys, basically, instead of like a writing response string as a type, return type, which this method returns, we um, we use this question mark so that like while writing the code, guys, don't think like we're gonna um don't think like think as what would happen after 5 years, what would happen after 10 years, what would happen um uh after someone came and wants to change the code. So we give some open doors basically to change. Honesty about the contract. REST controller advice handlers exist to say turn this exception into some HTTP response. The caller Spring, which is Spring, yes, only ever reads get status code, only serializes get body to JSON. It never needs the body's static type. Alright. Three, consistency across handlers. Alright, so this is the, I think, least important part, but of course it is important. So guys, I think we can make use of a break. It's been 3.5 hours almost. Let's take 40 minutes. 40 is alright. Let me exercise a bit and let me have my breakfast. Breakfast time. And I can't move it no more. What do you mean? I can't move it no. What do you mean? So you need a break too, like a exercise or something? Americano. Deep dives are too much of it. Like, yes, but this is where like you learn, like really learn. And if you manage to learn, if you can achieve to learn, the thing you learned stays with you almost forever. So this is this is quite, um, I mean, this is quite good, right? You learn once and you don't forget anytime soon, basically. So this is the beauty of deep dives, but they are hard. They are definitely hard. My dives are in abstract, interface, method, classes, super, extend, implement, override, strengthening. Oh my gosh, you've done a great job, Americano. Like, sounds amazing. Sounds amazing. Well done. Well done. Well done, mate. So now, I think we can take a take a break. Like, uh, not well. Why? Why not well done? Why? If you complete the deep dive, then you must feel amazing. I assume. It's like my first time learning calculus. I get something yet nothing at the same. So, like after a few years, all right, you're gonna see these times like a good time. So just enjoy the journey, basically. All right, these times are quite valuable for you. So just try enjoying the journey. So now let's take like a all right, trust, exact. So let's make four, yeah, 40 is good. 40 minutes of break. um See you after the break. I'm gonna have my breakfast and exercise and rest my eyes a bit. uh See you after the break, guys. And also decrease the sound of this sound a bit.
so that we don't want to make Americana jump. Bye bye.
Hello, welcome back, guys. Welcome back, Americano. Thank you. So now in this session, we're gonna continue with the banking system. We have so we studied the generic type over here and the meaning of this question mark, and we even went deep and see the implementation of response entity class. And also we have learned that by passing this string as an argument, we make the rest like a the object type of this method like this one, all right? Since like we see string over here just because the type of this get message, the return type of this get message is string. So now we're gonna continue with this handle insufficient funds method. Actually, we have completed it too. Now we can continue with, I guess. Let's see. So I guess we have completed this phase one. Alright, now we're gonna derive the next slice tasks. Let me copy this amazing beautiful SQL and run it over here. What do we have in these? I guess these are from yesterday's sessions. So guys, if you have any questions, you can ask. Now we are building a banking system in Java using Spring Boot framework, guys. Yeah. Welcome. Let's continue. So no ADRs yet. My architectural call on the roller. All right. Now AI is preparing an amazing to-do list for us. All right. We have created a controller, service class, response and request, and we also created our global exception handler so that instead of showing certain codes, we literally show a text. I'll be working on something else on Stream Arena. All right. Spring Boot is a bit outside of my target for now. All right. Since I still don't fully get the bit. Yeah. Don't worry about it. I do it because Java is the first language that I learned in uni, and also I want to practice object-oriented programming principles here, because I see some certain aspects of it that is used in other languages too, such as C sharp. I see this language as a shared knowledge among languages. So I'm just practicing. So that's all right, Americano. We'll we'll be checking you here. Let's see what you write. Uh, we don't see any code over here, Americano. Please type. Take care. Take care. Nothing yet. Also, I now know why it didn't light up back. So why? It was because I please go into next line. Press enter. Press enter. So it was because I said it on Python. All right. Totally understandable. Now I am happy that you figured it out. I'll be checking you while I'm developing Java. All right. Take care and good luck with your code. So now, guys, we back. Now that we back in our Java project, let's see what AI cooked for us. We can read the last line. The whole design intent of this slice is atomicity. Yes, the interviewer's favorite follow-up is, what if the credit fails after the debit succeeds? The transactional is the answer you'll get to prove with a curl rollback test. Run to start task one. So let's run this skill and start our next
task actually. All right. So let's see what we have here, like an account class. So we have written this class with its public getter setters, and we have a controller for account. We created, some of the methods here that uses that use service classes methods. All right. We basically, you know, do our so this creates an account. So let's open it. Inside it, I want to see the repository save method, so that's why I just wanted to open. We basically instantiate an account and save it into our database, basically using repository layer. All right, let's see what AI cooked for us. Two things to react to before I speak about package. A new transfer package, my recommendation, or stay, it says. New transfer package account. Account. Return type, what should transfer hand back? Let's first read what is written above. Task 1. Transfer service done. So again, now in this section, we're gonna create a service layer method that takes two IDs. I guess we're gonna transfer, basically, guys. Transfer money from one account to another, all right, with the amount. So all right. So it says that you already studied, this method and find by ID. I guess we're gonna use them too. Move money A to B atomically. Done when over balance transfer throws no partial debit. All right. We have some rules that we need to follow. The shape, one transactional method. So in all right, we're gonna create a service layer method. One transactional method, debit plus credit inline in that single method. Not by calling account services withdraw then deposit. Why? Like actually we have this method in account service. We could use it, but we don't. Let's see why. The whole lesson here is atomicity. So let's first open the withdrawal method inside our account service. All right. Create an account, deposit, withdraw. So for withdraw, we first get this account from our database, and then we have our compare to method that we have studied before, interfaces method. We basically get this big decimal of from our account and compare it with this one, and if it's sufficient, then we set our accounts balance. So we update our accounts balance. So this is withdraw. Why we don't use it? It is also transactional. So that's why I wanted to see this method. This is also transactional. So why do we need to have another class and another method? It says it is about atomicity, but I don't see the real reason. Let's read it. Body, they share one transaction. If anything throws after the debit, the whole thing rolls back. You'll prove that with curl in task 2. Why? The whole lesson here is atomicity when both mutations live in one transaction. So I guess our function includes not only withdraw, but one other action too. So we need a function that includes two functions basically, and we put them inside of a method with transactional. Let's see. Reusing withdraw would still roll back via required propagation, but it hides the atomicity behind two method calls and reloads. So I think what we are looking for is among these lines. Let's see. Order of operations matter. Operations matters for the guards. I guess we guys we may want to. So thank you for the explanation, but can you do it again? Because I didn't fully get the idea, the reasoning behind the creation of another class and another method inside it. Because as you said, we have necessary methods in our account service. So why not we use them? All right. Why not? Like before starting, I just want to understand the reason behind creating um, this new transaction class. It says something about atomicity, but like here we have like a transactional too. Maybe in even account service we can create another method and put call these methods. So let's see. Um, I also can update the topic actually. Yeah, I hope it's wrong. It's correct. So question one: why a transfer method at all? Yes. Why not just call withdraw and deposit? Yes. Imagine you skip transfer entirely. Your controller does. Yes, like this is what I am talking about exactly. Instead of creating a method, like we already have necessary methods, like withdraw and then deposit. Like this action requires two methods, two steps basically. Um, Commit. So we basically withdraw an amount from account A and then take that money, same money, and transfer it to other. Yeah. Each transactional method is its own transaction. Yes. Withdraw opens a transaction, debits A, commits closes, then deposit opens a brand new. I guess, guys, it's about making it fast. Instead of opening a database connection, doing your stuff, saving and closing it, and do it again for the other function, which is deposit. We get these two into one transaction because the goal, like there is one goal. So we can imagine this as a package. We create our package, we done, we do, we complete our package, and then we should close the database. All right, because database actions are you know costly. Now the killer question to one the one interviewer asked, "What if the Java version crashes?" Guys, forget about optimization and speed, but it's about correctness too. Because guys, like I didn't think about Java version machine crashes. Like I thought everything everything will be fine. Like imagine guys, withdraw method run, but and then something went wrong. That something could be losing electricity of that server, losing, maybe even crashes because our system does tons of maybe millions of requests a second, and maybe some internet connection, maybe Java merchant machine never crashes. The sky will never. Oh my gosh. Yeah, you're right, but it can, man, it can. Or deposit throw. So basically, we get money from one account, but we don't send it to other. So money is lost. So this is something we really don't want to happen. Don't want it to happen. So instead of doing them separately, individually, we should package them into and put it into one transactional method. That's understandable. It's not about it's not only about the optimization and the fastness of our code, but also the correctness of our logic. That's why a transfer must be one transaction. All right. Debit A, credit B, commits only if both succeeded. Any throw rolls back. Any throw rolls back both. That's the beauty. That's the beauty of this method. Now, if credit fails, the debit unhappens to unhappens. That's good word. A and B, like did I start the no. This is hmm. A and B both return to their original state automatically. All or nothing. So the approach is all or nothing, guys. This is the A in ACID, I think. It's the single most important banking backend concept. The transfer exists to draw the transaction boundary around to right. Question two, okay, but why new class? Yes, so like after determining we should create a package for our process, the next question is where should we store, where should we create this class basically? I mean method. Inside which class we need to create. Um, why not use account service again? Exactly, this is the same question. So this one's softer, it's organization, not correctness. You could put transfer in account service and it would work. My architectural call to extract it. Account service answers what can I do to one account. Hmm. Create, deposit, withdraw. Alright, alright, alright. Every method there operates on a single account. That's quite understandable. Like look at this word, guys, single account, because it's account service. Anything that it requires more than one account, you could think of creating a new class basically. All right. Um, is the sound good, guys? The sound coming from my. All right. All right. Let me. All right. Uh, so a transfer is about relationship between two accounts. It's a different responsibility. Yes, different responsibility. The T keywords, guys, responsibility and single account. It coordinates accounts rather than managing one. That's the single responsibility principle. Here we go, guys. Here we go. Now we've seen a concept, single responsibility principle. Maybe we can copy this one, create another, and ask, is it something related to solid or am I tripping? Oh, Carcass. There are some valid arguments to make it a new class, but words like single responsibility is like a clean code crap. Clean crap. Oh, I see. I see. Like, I was gonna ask, um, like there are some solid principles. Is this one of them? Um, can you please clarify? Like, I guess after a certain amount of experience, those decisions become easier. Uh, but at least during the interviews they ask, so that's why I practice basic. Welcome in, Carcass. T Carcass. Let's see. So yes, this is the first principle from solid single responsibility. A class should have one reason to change. Mhm. All right. The common phrasing, a class should do only one thing, is a bit misleading. Uncle Bob's sharper definition, a class should have only one reason to change. It should be responsible to one actor, one role. All right. Spring's layered stereotypes are SRP made physical. We are already using this in Spring Boot. One reason to change only talks to DP. So user repository talks user table basically. User service only orchestrates business logic for user. User controller only maps HTTP to service. Like, yeah, if you mashed all three into one class, so I wouldn't do that. It would have three reasons to change: database, business rules, and API shape. All right. GTK example. Uh, Single purpose IO decorators. Like buffered reader's job is buffering. Input stream reader is one job bytes to characters, and file input stream is read bytes from file. All right, let's continue. A transfer isn't an account operation. It's a transaction between accounts, so we need another class. That's logical. For exactly the reason, Stripe, banking cores, they all separate account lifecycle from money movement. From money movement, understandable. The honest part, for this tiny project, putting transfer into accounts I would compile and run identically, or other, but we are not like our goal is to prepare ourselves for huge systems, so that's why we learn how to position it well. Mm, but all of it. But we have met the methodistic. So like it already answered that. So all right, we can continue. Uh, Gives us our task AI. Let's see what's gonna be. Going with my recommendation, since you deferred new transfer package. Mm, all right. Now we have transfer package, and here we have our transfer service class and dependency injection, like a construction injection. All right. So that the life cycle of this is handled by the Spring Boot itself, not by us. So we have, all right, we have our first task. Transfer method we have, all right. Load both accounts. So we need to use obviously the repository. All right. Um, 404 if either ID is missing. So using this one, find find by ID, it would be great. We have maybe like we need to fetch these both, and this returns optional. So optional, I think optional account, right? Let's say from account. All right. All right, we have red, but we're gonna fix it anyway. Let's copy this and paste it again. And to ID, we can create two account. So now, so also it says that return 404, like 404 if anyone missing. Um, which how do we do that exactly? Maybe we just should return an error. Let's see the account service and let's see how it handles. So all right, so our magical method here, guys, this method, find by ID. Now let's see what it returns. Optional account. So yes, this returns optional account, and this magical method here, guys, is take looking into this box and try to find an account. If there is if there is one, then no problem. But if there isn't, then it throws an error. So um, and the left part shouldn't be optional too. All right. Find by ID returns optional. It's correct, but we have a magical method or else throw, and that magical method takes a function as a parameter. All right, let's copy this part. It takes a function. Let me also press enter over here. And if it doesn't find an account, it should return not found. Here, like as we have here, account not found exception seems great. So maybe we can just copy this part to new account not found. So I wonder where this is defined, but let's see. So ID will should be from ID. All right, and optional account, like I remember this. I remember this as this because I've seen this before somewhere. Maybe in find by ID itself. And if we look at the class itself, we are gonna see this T too. All right. So this is an interface. Like what I wonder is when a class implements this class, which in our case, a GPA repository class, right? Um, let's open. Let's open what? Account repository, and let's open GPA. So here, as you can see, like we have an interface. That interface extends another one, and we give types here. All right, all right, all right. Let's go back, CRUD, and then transfer. So instead of optional, it should be just account because our magical or as throw method works amazing and gives us what we want, what we need. I remove that optional. Actually, yes, remove that part. And after find by ID, which is optional, because it looks at our database basically. All right, and tries fetching that account, but we may not have it. All right, so new account not found exception, and we should put to ID here. So now the first step is done, is completed. Now the next one, reject self transfer from ID to ID before any mutation. Self transfer. All right, we can do this later. Reject overdraft on the source before reject trans overdraft. What does it mean? What does it mean overdraft on the source? Does it mean if we try to send more money than we already have? All right, how do we do that? We should check the amount of money we have, like the amount of money that from account has. So let's open account service. I think have we had some similar method here. So we had account, so we need to, all right, so we need to do this basically. So why not use with account services method here? Like I feel like we are doing the same thing. So maybe instead of typing it out, maybe we can just use account services methods. What do you say, guys? Because otherwise I will do the same thing exactly here. Like I will copy this part and paste it over here. Pardon, I missed that question. So the thing I wonder is like the transfer method transfers money from one account to another. And now as like in third guard, it says reject overdraft on the source before any mutation. So we need to check if the source account has enough money. And we have similar method in account service, which you know checks the balance of that account and see like check if has enough money. Hmm, should we use that method from account service, or should we type our own still like this one? Because I feel like I you know write the same code, just copy it. Like that could be a way. Let's see, let's copy and see what happens. Most probably AI will judge it and tell us to. So we basically get a count. I don't think copying it is correct though. Yeah. So you are saying that we should use the method from account service. For that, we need to have account service instance in our transfer service. Let's see. Um, all right. We get the balance. We compare to. So we compare this instance, this field, right? Is this object? Yes, it's object. Yeah, just call I think. But if it's me, I'll just copy it. Same thing. Anyway. I see. Um, like we compare a big decimal object with another, and if there is insufficient funds, we throw an error. If there is, we subtract the amount basically from. All right. Let's do the second guard too then. Reject self transfer. So all right, we can just add a if, basic if from id is same as to id, we can throw an error, I think. But how? Like this one, like which exception? Let's type it in this way. And our fourth step is debit the source, credit the destination, inline like withdraw deposit. So now we debit basically to destination account. How do we do that? We should again need to have the reference of our to account, and then in that to account we have set balance, and then we should set balance, like we should append the we should add this amount to the amount where this account has already has. So for that, to account get balance plus amount. Would it work? All right. Validate first, mutate last. A rejected transfer must write nothing. I guess this seems correct, except this exception error. But let's see how AI will judge. Mm, read transfer service class and judge it. Let's see how well we have done, guys. And let me use my eye drops once more. Like I'm looking at screen for a long time. and my eyes get dry, you know. Let's see. So read it. You got the spine right. Load both guards before mutation. Validate. First, let me answer your direct question. Then one back on that same line. Throw new which exception serves for substance. Yo, yes, there is no existing exception that fits self-transfer. Account not found. So in our, I guess, the global exception handler, we have like account not found exception and insufficient found exception, but we don't have anything else. Let's see. A new domain exception, save account. So like I would do this or illegal argument. So this is built-in error. My recommendation, the new domain exception, all right, is consistent with the code base and it reads all the call site, but not either way. Whatever you throw, global exception handler doesn't map it yet. It would become 500, not a 400 4xx. So in task 2, you'll add one handler for it. That's expected. Just flagging it now, so it's not a surprise. All right, so like typing the exception here in global exception handler is not enough, it seems. Pick one and we will wire it. One bug, send line. So let's see. We were typing transfer service and hmm, I think it is because I used this one instead of using that I would use equals, right? Yes, equals compares values. So do we have equals method in long class? Most probably yes. So from from id dot equals to id. All right, that's one. Long objects, not long primitives. So like I what I saw and what I assume like the two different things. Um, I mean what I saw and what I think I saw is was different. It is long object, so literal class, not primitive. So using this operator wouldn't help us at all. All right. The other one, so it says create another uh, like an exception line like others. Let's copy this part and try editing. So our name for our error is not valid illegal argument exception. All right. Actually, it is GDK built-in. Maybe ours should be same account transfer exception. So like we want this. All right. Handle insufficient. Mm, handle same account same account transfer. All right. And I think we should use same thing here. All right. So all right, interesting. We are getting this error. It's consistent with, but not either way. Whatever you throw, global exception handler doesn't map it yet. You'll add one handler for it. We need to add a handler. But also another thing is which status code we need to use here. All right, let's try to save the file and share both of them. I mean, transfer and then this or judged. So like I try to create an exception in our global exception handler, but the the class that I used is giving an error. This is most probably it isn't created anywhere. So we should create but where. Good, it was fixed. And you committed to the custom exception and already wired its handler. Now the bug I flagged earlier. Um, this won't compile, it says. Why? Get balance returns a big decimal, yes. So sorry guys, we don't like we are not able to use operators for balance. I mean big decimal. So instead of using um, plus operator, we should use add method because big decimal has one. All right, this one, this is one of them. Um, Java has no operator overloading. Works on primitives. I mean, and the spatial strings case. So, but not on objects like big decimal. Like we have operator overloading for primitives, spatial string case, but not on objects like this one. This is the exact same reason balance is big decimal, not double in the first place. Precision, precision at the cost of no operators. That's understandable. Precision is more important at the moment. Stakes are high. You already wrote the right form one line up. Look at line 61, your debit. So we are setting our accounts balance. We are getting it and then subtract amount. So um yeah. So credit is the mirror of that. All right. We used add method. Two things still needed to compile. Fill in the real throw now that you name it. Same account transfer exception. So I rename it, but like still we are getting like let me use it like this I think. All right, doesn't exist. Yes, so this is what I'm talking about. You reference it in both files but never created the class. Like how should we or where should we create it exactly? Let's see. Where should we create it? So you reference both files. You'll need a new file, same shape as insufficient found exception. Extends runtime exception. So insufficient found exception. So let me find where it is. I don't see it. Insufficient found. So this is here and it extends runtime. So in again account, I guess we need to create those exception class. New file .java. So we can copy from here. Mm, we can copy the name and all right, that's us. Now we have runtime like we our exception extends runtime. So by extending, We are basically inheriting all the messages, not messages, but properties, methods. All right. And also, we basically make our Spring Boot framework to recognize this. All right. This is important as a, you know, exception. Now, let's open our transfer service and like this should be fine. How do you throw error? So maybe I shouldn't use this one. No. Why am I getting an error still? Let's see. All right. One constructor taking a message. So I think we didn't add the message it wants. Maybe we can just add, you know, error. Same account error. But still we are getting error. So let's see. One design thought on your new handler, your call. You mapped same account transfer. Yes, we mapped it to this conflict. Worth a beat. Um, your request conflicts with the resource's current state. That's why insufficient funds is this one. It depends on the balance, but self transfer is bad regardless of any state. Same idea is just a malformed request. So that's a better textbook definition of 400 better request. So it says that inside global exception handler, instead of using this conflict, we should use 400, which is bet request. So instead of conflict, we should give this. All right, save it. And in here, like, why am I getting an error still? So maybe we just need to pass the class again and let the AI judge it, guys. Um, because I don't expect getting an error while throwing this exception, but transfer logic is correct. Set transfer throws cleanly, guard set before mutation. Yeah, cannot result. Maybe, guys, we should implement. I mean, not import. I mean, yes. Look at the top of. Hmm. So maybe, guys. Yes, as as we did here. Uh, what was the name of the error? Same account transfer exception. We should implement this label, I think. So thank you for mentioning about it. And the thing I wonder is like, are we importing the label exactly? Or like, what is the logic of this import statement? All right. Basically, we don't initialize it, but we make our current class reach for labels, names of those classes, methods. What is the core concept, underlying concept about like this import basically? Let's see. Now we have like here cloud agents skill, I think, or command. I don't like creating lots of agents anyway. One or two is enough. Your intention is exactly right. Import is about names, not loading. What import actually does is compile time alias. So yes, this is what I'm looking for. Every class has a fully qualified name, its package path, plus its simple name. So this is the package and this is simple name. That long string is the class's true globally unique identity. You could skip import entirely and write the full name everywhere. Alright. That compiles fine. Ugly but valid. Alright. I totally get it. Why it is needed simple names aren't unique. Alright. What does it say now? The contrast take that makes Java click. C's include physically copies text. Python's import runs the module. Java's import does neither. It only resolves a name. Oh, that's different. Like in Java and in Python and C, those import keywords does different jobs apparently. That's the cleanest way to hold it. Java import. Which class does this short name mean? Name mean nothing. Hmm. All right. All right. Now, how should we continue? So we created our class transfer service. We created our methods, not method, but transfer method is transactional. And instead of using the same method in account service, we type it again. Like after it compiles cleanly, I'm gonna ask what would happen if we use the methods from account service. I really wonder because like it's like duplicating, right? We have the same kind of method in account service, so why not use it? Task one is done. Compiles green overbalance times throws before any partial debit. So task one seems completed, guys. One unresolved decision. Same account transfer handled currently returned. Like I did change it. Not this one. In global exception handler, yeah, I save it too. Once you settle that, two moves. Service plus self transfer guard. Task 2 transfer controller. Now we can create our controller. We can create our controller and call this method. So before continuing with that, thank you. But I wonder what would happen if we use methods from account service by initializing an account service object inside our transfer service. Would it be just wrong? Because we have almost the same methods in transfer service. What do you say about it? Creating an service instance inside another service, is it wrong? Let's see. Oh, hungry hippo. Thank you for the follow. By the way, I have missed it. Welcome in. Um, hungry. Welcome in. Um, let's see. Let me fill my water because we have like a similar methods in account service, but we we have written our own. Let's see the explanation of AI for that. Two two different questions hiding in there. Let me separate them because one answer is yes, wrong, and the other one is no, actually fine. Um, like look at it, guys. Like this is good. explanation. Question one: new account servers inside terminal servers. Yes, that's wrong in Spring. Hmm. Account servers, same repo. Don't do this. Two reasons. The second is the killer. Reason one: you defeat dependency injection. You would have to hand its account repository yourself. You would have to hand it its account. So let's look at it. Look at account service again, and inside of it, we have a dependency here. All right. So like actually, I'm glad that I asked this question because guys, like of course you can instantiate account servers by yourself. Um, but the thing is, then you would have to inject this one too. Otherwise, you wouldn't be able to use that one, all right? That's why in our account controller, for example, um, like we again, like we don't basically initialize anything, all right? We let Spring Boot to handle it because here, as you can see, we don't initialize it, all right? And the Spring does it for us. So Spring um, understands this dependency and handles it for us. That's amazing. You would have to hand it its account repository yourself. Where do you get that? You would need like we would have to create that account repository too. And actually, we first need to create account repository and share its reference into the constructor of account service. And then we can we would be able to use its methods here. So that's a wonderful question, honestly. Um, let's see. You would need that too, and its data source. It also has data source. What is that? Like in account servers, what is data source? I don't because I don't remember anything like a data source here. So on down the chain, dependency injection exists precisely so you never assemble this by hand. Spring builds the whole graph and hands you finished beans. Finished beans. By finished means it means like a classes, like instances that has like that we don't worry about creating their dependencies and injecting them. This is what it means. So reason two, transactional would silently stop working. Oh, why? So, like, imagine, guys, in transfer servers, imagine um, we just, add another, add another services instance, and then this transactional would stop working. That's interesting. That's interesting. This is a deep one. When Spring creates a bean, it doesn't hand you the raw object. It wraps in a proxy. So yeah, so this is the term I've seen before. A generated subclass wrapper that intercepts your method calls and adds cross-cutting behavior. Open transaction, run your code, commit and rollback. Transactional, cacheable, asynchronous, all of them work through that proxy. Spring managed. So caller, proxy begin, account service withdraw. You knew it. I mean, you instantiate it. So account server withdraw. Mm, all right. So I guess we can take a quick break, guys. Um, like a 10 minutes. All right. After I come back, we're gonna continue with this proxy thing because we learned that we cannot create our own. I mean, we cannot instantiate our own service to use its methods over here. And but instead of that, we created our own. added to these lines where we compare, check the balance, and insert, transfer the money basically. This is quite interesting because even if we try to do that, we would end up with an error. We would end up with having transfer method not working. That's quite interesting. So now let's give a 10 minutes of break, guys, and look at what Americano Beans written here. So let me decrease the sound a little bit, and then uh, 10, even maybe 12. Hello, welcome back, guys. Welcome back. Now, our goal, I mean, what I want to ask is like, I don't want to spend any time understanding proxy. It is important, but um, realize that, guys, we have an interface. Like, it was interface, right? Yes. We we are adding an interface over here, and Java, I mean Spring Boot frameworks handles under the hood. I think it creates a class that implements this interface and use that for us. All right. And my question is, my like before continuing, my question is dependency injection um, related to only the case where we use interface and we use that interface in the transfer service constructor basically. So or we could use I guess we can or can we use a normal class and without instantiating it um, we just use its reference and use it in constructor of the current class, because I remember I asked this question before and I've seen that even we don't need to use Spring Boot, we can use this approach in our normal Java code basically. All right, let me send this message. And also, why I don't hear. All right, I guess it is better. So I guess it's saying that we need to change the number we have here for our error message. And where we have it, like we already have changed it actually to bed request. And we also today studied this type response to this. So why we have here string here? Because this method, you like when we look at the definition of this method, you will see this t here and see that the return type is t. I mean this. So that's why. And let's see what AI told us. Come on. So sharp question. You have half answered it yourself. Let me confirm and separate two things that often get fused. DI is not about interface. It's about who creates the dependency. It's about dependency. So like the name of it is actually depends. So all right, dependency injection. Like so, what I mean is dependency can. All right, this has my full attention now. What? So here, like dependency can be an interface apparently, All right. Um, Here we have account repository, which is an interface. All right, and we are using it in our constructor. So anyone who wants to create an instance of this transfer service would have to inject this. All right, that's why we use Spring Boot framework, because uh, it handles this process for us. It's about who creates the dependence. Dependence injection means one thing: a class receives its collaborators. Oh my gosh, I see this word used for dependence injection. That's awesome. Collaborate. This is really the collaborators. Because like in service class, we literally use the methods of this interface. Um, a class receives its collaborators from outside instead of creating them itself. So here we don't create it, we pursue or we receive these. I mean this interface implementation basically from outside. That's the whole definition. Interface or concrete class is irrelevant to the definition. All right. Proof is sitting in your own code right now. I finally understand what interface means. Oh my gosh. I'm glad to hear that, man. I no no. You got it. So account repository is an interface. Spring generates implementation and inject it. So here in account service we have also like this dependency. Account service is a concrete class also injected in the question Q2 version of we discussed. All right. Yes. Hmm. I guess this is another example because we have account repository here. All right. Uh, so same mechanism. Once an interface, once a plain class. So it tries to say that uh, we can we can have dependencies injection to we can have dependency to concrete class or interface to. It doesn't matter. Only thing is we receive these from outside. We don't have their um, implementation, not implementation, but instance basically. Yes, same mechanism. Once an interface, yeah. So, and you are right. DI is plain Java, no Spring needed. Yes, this is the part you remembered correctly. DI is a design pattern. DI is a design pattern. Language level older than Spring. Here it is with zero framework. Like we have a repository here, and this repository obviously is an implementation. All right, we have repository instance, and we share, we inject this instance in our transfer service constructor. So this is a dependency. Like transfer service has dependency to account. I mean, account repository basically. Oh, welcome, welcome. The game bill 087. Welcome in. Well, welcome. So this is the dependency we have. Don't mind me. Just all right, all right. Thank you. Thank you for stopping by. So transfer service doesn't so doesn't instantiate its own repository. You hand it one through the constructor. This depends. All right. What Spring adds is not the AI itself, it's the automation of the wiring. Without Spring, you write those new lines in the right order and pass everything by hand, the object graph. With Spring, you annotate like using these basically, these annotations, and the container does the newing and passing for you at startup. Oh my gosh. String is a DI container. It performs DI on your behalf. On your behalf. It didn't invent the concept. All right. Um, where interfaces do come in, interfaces aren't required for the eye, but they are common companion practice. Depend on an interface, inject a concrete implementation. Yes, that buys you swappability. So yes, I totally get it. So another reason is that like we use like an interface here instead of the implementation, because we can have multiple implementation. I mean, multiple implementation of the same repository based on our needs, and using like an interface over here, we can pass all of them. All right, we can pass all children here. But if we designed this using concrete class, and that class doesn't have any children, um, in future, maybe in 1 year 2 years, when we need to use another implementation, another class, we would need to change this class. But as a good design pattern, a design principle, we shouldn't do that, because the class we have written should provide this. How? Using an interface. So the only thing we need to do is creating an implementation of another implementation of this interface, and then um, basic use. But like, of course, this example is not about um, Spring Boot framework. I'm talking about object-oriented programming wise, because here Spring Boot framework creates the implementation of this interface. All right. All right. So maybe we can take a screenshot of this one. And this is about interface. Swappable implementations. Yes. Let me, not this one, but this one. Here, OCR and add interface. I guess we have one. Interface, yes. All right. So, you can read that file again, because I have changed it to bed request. I mean, our handles same account transfer method. I mean, same account transfer exception now uses bed request. Check it again, and then continue to our new task, please. Now I just want to do. I just want to continue with our next task, guys. Correct all. Self transfer is a malformed request, not a state conflict. So, all right. Let's see. Build success. Task one logged in. Let me look at your account control. So I scaffold a new controller. So I guess now it's time for us to create. Actually, we have account controller already. Yeah, so task 2. Got your controller style, thin adapter, record DTOs, return the response object directly. Let global exception handler handle errors. So here's task 2. Transfer controller. All right. Yeah, so decision for you. The fuzzy part from task markdown document. Transfer returns void. So what does post, I mean this endpoint, respond with? 200 with nobody, or the two updated accounts? So this is basic design decision. There is no wrong answer, but I think 200 would be great, because, or 200 with two updated accounts. Richer needs account service injected and a transfer response DTO. Controller rereads both after the transfer. Mylene, it says A for now. It keeps task 2 tiny, and the rollback proof is just get both accounts before and after. You can upgrade to be later. All right, if we can, then do it later. Uh, Ticked A, because in future we may need to have, you know, we may need to know about those accounts, maybe other fields, because we are designing an API. Uh, so that we need to think about the future too. Right now, it is all right just to see if the transfer has been completed uh, without an error or not. All right, your keyboard one line. The in the transfer method body is the same shape as your. Pull the fields of the request record. Like I didn't get it, guys. So all right. So it created transfer controller. Let's look at it, guys. This is task 2, phase 2A, thin HTTP adapter for money movement. So our endpoint is transfers. When someone make a request to this address with post type, to do you type call transfer service transfer. So in caller we need to call the service method. Which method? Transfer method. So do we have the reference for service? Yes. All right. So in service class we have dependency or to the repository class, which is um, interface, and here in controller class we have dependency to service class. So Spring Boot should, like a give the instance of it at the startup. Well, since we have the reference, so we can obviously use it. Transfer service, transfer, not serve. Transfer service, which method? Transfer. And which parameters does it get? Does it, yeah. Can we see it? Maybe, so from ID to ID and amount. So do we have them? Actually, yes, we have them. From where? From request. So let's see transfer request here. It's a record. Inbound DTO for, all right, what the client sends to move money. Record immutable data carrier. So last time we have seen this, we didn't know the meaning of the record. Here, immutable data carrier. Jackson binds the JSON body via the canonical constructor. No balances here. The client, we only have from ID to ID and amount. Client names the two accounts and amount. The service reads current balance and enforces the rules. The service reads current balance and enforces the rules. What are those rules? All right. So in our, I suppose in our request we have from ID, but is it a method? I guess it is about this record thing. All right. We hit this before actually. I asked this question before. So we have request dot to ID, wonderful. An amount is also coming from the request we had. Request. What happened? What is happening? We have request and an amount. So we basically use the method of from service, and how do we do that? We have the dependencies. Dependency. So I guess that's it. See, let's see. Like, do we need to throw an error or something, or is the is like I mean the transfer method provides us? Yes. So we have written these I mean necessary exceptions here inside the core method itself, not from the controller. So I guess we are good to call this um, transfer controller, read it, and judge it. Let's see. Correct. All right. This was easy. So basically, for service method, I mean, for controller, we need DTO for controller because controller is the place where the request has, hit first, and this is where we have the ability to read the content of the request. So that's why it should be in a certain format. Task 2 done, and the phase 2A slice is complete. Money moves atomically over HTTP. All three error paths map correct. All right. One senior level nuance for worth seeing before we commit. Your transfer validates before it mutates. Yeah. So in test 2, the debit never happened. The guard threw first. That means test 2 proved your guard, not the transactional rollback. Both balances are unchanged because nothing was ever written, not because a write was undone. So, where does the rollback actually earn its keep? The failure you didn't foresee. Your guards catch the known bad cases upfront, but imagine crediting B hit a database constraint violation, or GVM died, Visual Virtual Machine died. So some deeper level exceptions, what I see from here is some deeper level exceptions I can come from like a you know database database consent violation, or from our Java virtual machine after A was already debited. So that's when transaction saves you. So how do we test it exactly, guys? It undoes the debit you can't manually take back. Mhm. Validate first handles the expected transaction is the safety net for the unexpected. Yes. A well-designed service has both, exactly like yours. The I am a visual learner. Please make this animation doesn't work. No, no, it wouldn't work. Like I guess you would need to use like a terminal version of it. I guess Gemini has one too, right? Like a Gemini CLI, something like that. Which animation you need? We can create it after the stream. Which animation? That distinction, guard versus rollback, expected versus unexpected. Yeah. So interview, answer. Let me know that and come. I'll just read the. Alright. um. All right. So I guess it has wrapped up. Next move, adaptive replan, concurrency optimistic looking. Oh my gosh, that's a good topic. So let's replan. Hmm. Now, guys, a fun part. Watch two concurrent updates race. Wonderful. Adaptive replan. Like I really wanna see it. Uh, like yeah, we are going great, we are going great. So we created controllers, services, we use dependency injections, we use DTS basically. Now we can do some processes over HTTP. So someone will make a request, we will handle it internally, make database call, and read, write, and then show the result back to the user and save the maybe progress. um, these are essentials basically, but the next thing we're gonna see is something cooler, like a concurrency, which is awesome. So great, great. Let's see. Maybe guys, today after the stream and after I rest a bit, we can do study with me session 2, maybe for a couple of hours, because after the stream I just don't want to study or and now I need another push. So I would be glad if you join me 2 streams in a day. Yes, yes, because I need it. I needed Americano. The streams make me work harder, literally. Then imagine both being no, 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 no. The second one, like for like, but Americano. I have a surprise for you. Like I have an idea to share with you. It is how about we stream 18 hours on Sunday, on this Sunday? What do you say? Wouldn't it be great? We can take a 1 hour. I will. No, no, like, no, no, like, you can't die. Come on, we are young. We can maybe like a like 1 hour break during noon, 1 hour during like at 6 p.m. And between each break maybe 15. The 12 hours last time made me dream of Java. Oh, so after the stream, in your dream, you saw Java. That's great. That's what we need. That's what. This is exactly what we need. Like start seeing the objects around yourself as real Java objects. That means you internalized those concepts, which is us, right? Like I imagine doing 18 hours stream on this Sunday. Uh, mm, we can study lots of LeetCode problems. We can review them. We can solve new, and then maybe study Python during the times when we feel low. We can prepare our drinks. Um, yeah, like that sounds great. And also, until Sunday, I wanna prepare those videos. Actually, the reason why I want those study with me sessions is that um like I wanna send you like a pre-stream note so that you can practice, guys, everyone. And during the stream, you can ask me questions about them. And also, like I like the reason why I want to do the second stream during the same day is that preparing those videos, because we study amazing, guys, but we definitely need to summarize them. This is too long. Okay, 10 hours is too long. It should be 10 minutes. All right, I will try. I'll be at home this Sunday, so I won't be able to participate I see. So study with me. Yes, yes. I mean, like in study with me, like I won't share my screen, and maybe during the breaks we can talk. But while studying, I wanna create those videos basically, those short videos. I wanna watch the previous streams and extract valuable short knowledge and summaries, and upload them on YouTube. Basically, we need them, guys. We need them. Oh, seems interesting. After this, then sure. All right, all right. So now our next task is about concurrency. It seems. Let's see what it is. Task one, version on account. So like I don't know much about this annotation, guys. Java has lots of cool and interesting annotations that does a lot of things under the hood. Things a lot of under the hood. Um, we have a version annotation on account plus uh, surface version in account response. Phase two be concurrency safe writes. Um, make the make the version observable. Then done when boot logs a version column, each write bombs version visible via get. Oh my gosh. One field on account version private long version that single annotation. Philips hibernate into optimistic looking mode for this entity. Every update becomes update set and version. The var finds no row if the var finds no row because someone else already bumped the version. The write fails. Alright. You owe nothing about version's value. Hibernate reads, checks, and increments it. You never set version. Alright. Then thread version through. Alright. Honest design note, your call later. Accounts response own Javadoc says version must not leak onto the wire. For production, that's often right, or you would expose it as an HTTP tag. We are exposing it here purely to observe. So it means that we usually don't do this in production, but since we are learning and testing, we can do it. What I will scaffold versus what you'll type. I scaffold nothing. You edit account. So basically, guys, we need to update this entity and add a new field. First move, start with confident half. Add version to the account response. So this is a record. This is a constructor. Like this record thing, like, alright. We are basically returning a new account response based on the account that we got. I think, yes, now I remember, like we write fields, I guess, into this record here as constructor parameters. Add this version to the account response record. The component in the header and the from factory. You threaded a record component before do that, then we tackle the version. Two things before you type. Version import, it comes from Jakarta persistence, which account already imports. So no new import needed there. The fuzzy bit, so it says that we need to add version to account response. Like, and it also says should we use long? I didn't get it. Like this one. Type long, and even better, press space, long version, and then it means that in account we should have a field for account dot version, but we actually not verb, we don't get this field like this, but get, I think, get version like this. But the thing is, in account we don't have it. So in account we can add version to account response first, like we add it to account response first, and then record component plus from. This is component part, I guess, and this is from. Then we do the version field on account. So we just need to create private long version, and most probably we should add a version thing so that Hibernate does some necessary stuff under the hood for concurrency. This is a special field, so we need a getter setter for this too. Set balance, get balance. So maybe here public void set. Actually we don't set because Hibernate will handle it for us. Maybe get we need like a long get version, most probably, I assume, and we're gonna return this dot version, I think. Save it and also save it, I guess, please. All right, so now read account and account response classes, please. Oh my gosh, what did I do? Band Americano. I didn't do that. Most probably I accidentally. Let me find. Oh my gosh. Hold on a second. I accidentally banned. Most probably here. Hold on. Americana. We need to fix this issue. Moderation, I think. Mode management. Actually, that's interesting. That's interesting. Let me ask AI. Let's see. I think I accidentally banned Americano beans. I don't know how it happened. And let's give me a sec, guys. I want to fix it. Most probably I accidentally click on it, but let's see. And the task we have, It's quite interesting. How did I do that? There is a command for that. All right. Americano, can you type? I don't know how I did this. It is because of my mouse, I think. Anyway, now we are back. We can continue. Sorry for that, mate. Sorry. Now, two calls before we go. Demo mechanism: temporary slow deposit endpoint. My hands runnable or unit harness. Start with piece A. Write the object optimistic looking failure exception handler. So let's see. So we should first create an exception, standalone exception that no problem, no problem. Thank you, thank you. First, we should create this exception that extends runtime exception. And in our global exception handler, we should like do this stuff. Which status fits someone modified this row before you? Hmm. Already, maybe already updated or something. I don't know. Tell me your demo choice and write the handle. So maybe guys, object optimistic looking exception. So let me this for account new file this dot java. All right, and open an exception and like copy this part basically. Which part? This part, which is awesome. And let's copy this part too, paste it, object optimistic looking failure exception. So this seems legit. And in our global exception handler, just copy it completely, paste it, and use this name. Which name? This name. And the same name for here. And now like we should find a code basically, but which code we can use? Like imagine we are trying to update a value that is already updated, so we shouldn't do. Let's go http status and try finding some for 400 messages. Not acceptable, method not allowed, proxy authentication request time, conflict, gone, blank required, preconditioned failed. Interesting. Payload too large, request entity too large. Which one we can use? Like unsupported media type. I am a teapot. What is this, guys? Insufficient space on resource. Destination locked. It says deprecated, but like this sounds reasonable. Locked. Yes, I guess we teapot. Yeah, like there is a like 418 error, and the label for it is I am a teapot. Like, what is this, man? What is it? And maybe ours should be locked, guys. Like, it seems quite correct to my ears. Let's use it, save it, and what else should we do? Temporary slow deposit endpoint. So um and it says endpoint, so we should create an endpoint in our controller. Deposit, maybe we should slow deposit, yes. Mm, so oh, it was an April Fool's joke. Ah. That's interesting. That is interesting. um so now, like, should that method post type or get type? Since we are gonna do some write operation, it should be, post. Let's copy this one, all right, basically, and copy slow deposit too, all right, and slow deposit, and we cannot use this, all right, so slow deposit, hypertext coffee pot control protocol. That sounds interesting. Slow deposit method, and here we're gonna call, guys, one of methods that is in our account service, or we can use transfer service too. Let's see. Temporary slow deposit endpoint, myrec hand runnable, or unitarnus, Google teapot. Let's see. I am a teapot. The request entity body. Um, I cannot know. Like, I am a I am a teapot. Request entity body is short. Tip me over and pour me out. Like, the drawing is also good. Oh my gosh, this, I like it. So in account controller, guys, slow deposit endpoint. Start with piece A, right? All right, we have already. So we have already created object optimistic locking exception, and we added it into our global exception handler. And where should we, like, in account controller, how do we design this method? Check account controller 2. Let's see, account controller 2. Let's see what AI will tell us, guys. Like, we have, like, I tried to create an endpoint, and there, like, which method, like from service, like account service or transfer service, we should call, and which method, basically. Actually, most probably we don't have it yet, because we need to create a method that runs slowly. Let's see. Stop. There is one serious conceptual bug here, and it is the most important thing in the whole task. Let me show you, because it ties straight back to import lesson from earlier. You created a class that must. Which class? You made your own, yes, in the account package, yes, but that exception is Spring's, not yours. When version detects a stale, right? Hibernate, Spring throws, or ORM. Like look at the package name, guys. By creating your own class with same simple name, line 45. Mm-hmm. Line 45's now binds to your class, same package means the the one nothing ever throws. So when a real log conflict happens, Spring throws it. Your handler doesn't match it. It falls through 500. The handler would silently never fire. The task would look done and be broken. Like I don't like I understand that now if we use like if we create our own exception class, like we basically uh like we shouldn't do that because Spring in Spring it has the very same error. So I totally get it. But the thing I don't get it, what happens if we write it? Like it says task would look done and be broken. But why? Like, again, we have another exception and we, you know, bundle it. So what is wrong with that? Mm, I think it is because imagine these exceptions like a long path. The error that version throws, like of course it is object of this one, but when you look at the whole path, you would see another one. Like you would see this one, all right? But ours is not. So that's why we won't be able to uh, catch. So let's remove it, move to trash, and remove it from our global exception handler and save it. All right. So I understand that the annotation throws that error already. All right. The distinction compared to same account. Yeah. So wait, never mind. Is it protected like Java line? Like I really wonder how is it designed, Java lang. Hmm. How can I like? Can I click on this? No. But this one. Hmm. Maybe we can create a class that imports Java lang and open. All right. Distinction compared to same account transfer exception. You get that one right, and the contrast is the whole lesson. Yeah, I get it. I get it. So you throw new. Yes, your domain exception insufficient. Yeah, exception like this exception apparently a special exception. All right, that we are not the owner of it, but the that annotation is owner of it. So do that. Then two smaller things I'm holding. Not now. After fix. The status online. Yes. Web dev. We set conflict. Reconsider when you are there. Like I remove it too. So what are you talking about? Fixed. So now I deleted that exception class and in also in our global exception handler. Uh oh, you are saying that I can keep this one, but I'm getting red. So maybe I should import that. Like I mean, I should import object optimistic looking failure exception from that package, right? So for us to be able to use this exception, guys, most probably we should, yes, yes, add the import. All right, we should import it. So we import classes, interfaces, and also exceptions. That's interesting. And now we are able to use it because now this name is resolved with the correct path. All right. Now instead of locked, it says, I guess we should use conflict. Conflict. So save it. I have done mm, removed that class and add that import line and also change to conflict. Let's see. Now what we have done, actually we only add this one, right? And also in our controller we try to add this. All right. So then, like after writing this one, I realized that we made a mistake to create our own exception for this exception because Spring already provides that exception for us. So we just need to import it and use it. Let's see now what AI says to us. Build success. Piece A is correct. Your handler now catches Spring's real exception. Wonderful. So now this is the first time we see to catch a Spring's error exception. How we've seen how do we do that? How we do that? We basically import that exception and write it over here. That's it. For our own exceptions, we create a class that extends runtime exception. Like we can see that this keyword like um, that's something that turns our class into powerful mode basically. Because extending mean inheriting, and if you inherit properties methods, you like the Spring Boot framework can use your class as if you are runtime exception. All right, and the difference between then you can say why not just use runtime exception. It is because our exception has different message. That's why basically. And if you open runtime exception, like look at its fields, like it has this one, a constructor, what else, and, and I guess another constructor. Now with two, three, four different parameters, and this is somehow protected. Maybe guys, I can take a screenshot, and this is good example for of course you guessed it right, protected keyword. Apply OCR and pro. Let's remove it. Protected. All right. Because authors must have their reasons for making this method, I mean constructor, as protected, because this method, like this keyword, means that um, you cannot call it basically outside of the package. Which package? This package. As Americano said before, Java lang, like this is Java lang, and but he said, is it like Is it protected like Java lang? Like I thought that package is protected too, but I don't think we can use protected keyword for packages, but instead class um, methods basically, and classes, yes, classes too. Here we have this keyword for the constructor itself. um, all right, let's we cannot all right, so let's copy this part. Before we continue, wanna ask that I just wanna ask that why do we have runtime, like why do we have a constructor for runtime exception class which is protected? And I'm asking this to learn and practice protected keyword from object-oriented principle perspective. As far as I know, we cannot call methods that has protected, mm, let's say, keyword, ident modifier basically. We cannot call them outside the same package. I mean, it should be in the same package, right? Oh, extends just means I am it basically, yes. And so insufficient fund is a type of runtime, yes, yes. So the Spring Boot framework can trust your the exception that you wrote and use it as if it is runtime exception. All right, because Spring Boot needs exceptions to be in certain format, to have certain methods, certain fields. Instead of writing those methods, fields every time by ourselves, we just extend it and make our Spring Boot framework able to use our own custom defined exception. Exactly. Let's see. Good question to drill. And there is a precise correction to make because your role is half right. Protected is not same package only. All right, let me fix the mental model, then the constructor makes total sense. Private is for making a method for being able to use only in the same class. Default is same package. Protected, oh, like protected has the another feature, subclass. So imagine protect, like imagine you have a class and that class has children, all right? And but imagine you create that child inside another package, all right? So protected makes that subclass to be able to use your own method. So basically, if your child is far away, he or she still can inherit, right? So we basically by using protected keywords, we basically make our children inherit our uh, fortune, all right, let's say, entities from anywhere around the world. Oh, so protected is just me and my children can use it. Yes. So so protected has less constraints than private. Yes. That's so trippy. Yes, yes. So private is the strictest one because it allows only the same class to use that method, nothing more. As like you cannot call from outside. Protected makes even more. You can call it from other packages too. And if you don't use any keyword, you can use in the same package, in the same class and the same package, but not other package. Carcos said that extends is also the most dangerous keyword in object-oriented programming. People don't take time to think about architecture, and you end up having 5+ levels of inheritance. Yes, yes. Actually, there is a idiom saying that all you want is a banana, and but you end up with monkeys and with you know um, the mountains, the environment, and everything. So all you need is to take a banana, but you end up with getting banana, monkey, and the forest. So I guess the danger of using extend keyword is this. Um, yeah, it also like helps you code faster, but if you don't use it carefully, you'll end up with getting and fetching a lot of things at the same time that you don't need basically. Exactly. We need to use these strong keywords carefully. So the row you are missing protected, yes, package private plus subclass. So I keep forgetting it, guys. So protected means protect the inheritance of my children. If you pay peanuts, yeah, kind kinda like that, like let me ask AI. Actually we can ask it too. There was an idiom for inheritance in extend keyword saying that all we want is banana, but we get banana with monkey with forest. I guess it represents the danger side of using extend keyword. What was that phrase exactly? Like kinda that one. Let's see. So protected makes this constructor to be able to call from outside our package. The code, guys. What was it? Gorilla. Oh, the problem with object-oriented languages is that they've got all this implicit environment that they carry around with. You wanted a banana, but what you got was a gorilla holding the banana and the entire jungle. So yes, so this is a common. Okay, let me copy and paste it. Like pasting is kinda gorilla holding the banana and the entire jungle. So yes, this is what Carcos said. This is just like that compared to no, compared to was the highest, like I really like. So this is a little bit in lower levels. The problem with object oriented languages is that they've got all this implicit environment that they carry around with them. They wanted you wanted a banana, but what you got was a gorilla holding the banana and the entire jungle. Yes, this is the code, but not the monkey. All right, your poor forest. um, it's the classic critique of inheritance when you extend a class to reuse one method, the banana. You don't get just that method. You inherit everything and all its fields, all its other methods, its constructor chain, its whole protected surface, its invariants, its bugs, and the gorilla the jungle. You are now coupled to the entire superclass, not one thing you wanted. Concrete in your own code. All right. So when we extend runtime exception, drags in all of runtime exception throwable objects. So when we do this extend runtime exception, we don't only extend this class, but it's all chain of all chain basically. So meaning we also inherit exception class, we also inherit throwable and object. Um, Stack traces suppression, machinery, serialization, get cause the works. Do you want an unchecked exception with a message? Yes, the banana. You got the whole throwable jungle for exceptions. That's fine. You genuinely want the whole machinery, but it illustrates the point. Extends is all or nothing. Hmm. That's a good theme, guys. Extends is all or nothing. So when you use keyword, you basically get everything. Extends is all or nothing. The lesson it props up, the code is rallying cry for favor composition over inheritance. Yes, favor composition over inheritance. You are studying that, yes. Dangers it points at, fragile base class. The gorilla changes, your code breaks, and you didn't touch anything. Oh, like one of the downside of using this inheritance is that imagine you make a change on the base class, on the one of the parent classes, and as a side effect, maybe you broke something, but the child, all right, didn't do anything wrong. Child was innocent basically, but um, we affected it. You can't take just the banana, yes. Tight coupling. The jungle comes along, whether you reference it or not. Composition. So, guys, another like a commonly asked question is, uh, why do we should you why should we use composition over inheritance? Um, just open what you are extending and the one it extends, then just copy the code. Yeah, you can do that too. You can do that too. But most of the time, the implementation of those methods are kind of complicated, and most of the time, the chain is not one line. So that extends other, that extends other. So basically, if you even if you copy the code, then maybe I can just ask this question. Like this question is really amazing. If you wanna like get rid of this like a jungle issue, why don't we just copy the code from the parent and just instead of extending we just use that method? I have an answer for that. It might be because of this chain. You would maybe need to copy the code of parent's parent. All right, that's my answer, but let's ask AI too. Like that question is good. That question is good. So composition is hold a reference to just the banana. Oh my gosh. Let me copy it. Guys. Extra goes here. And then what is it? Composition, guys. Composition. And then inheritance. Wonderful. And also let me assign a color. I think because it will clutter everything and just creates bloatware. Like let's see. Like that's a good question because this is logical, but there must be some reason not to do that. So composition is hold a reference to just banana, just the banana. So for example, stack composition has a relationship. Yes. So versus stack extends array list. Inheritance is a list. All right. Extends and implements. Let extends and implements are is a relationship, right? Let's go back. So, like, we can use this field by composition or by inheritance because as we extend this array list, we have its fields too, basically. Composition has a relationship. Yes. The composition version exposes only what you choose. The extends keyword leaks every array list method onto your stack. That's the problem, guys. Like, imagine like you extend something and that something has a chain of 4 classes. You basically gather all of them and put into your stack. That might cause a problem. So that's the issue, including ones that break its last in first out invariant. The gorilla. At this one, remove 5. So this is good, guys. Let me take a screenshot and paste it inheritance and not protected. What was it, guys? Composition. Why don't we have composition over here? Compo. Like, I think we should learn this too, but later. This connects to your earlier extend versus implements node. Implements and interface gives you only type and contract, a banana shaped promise, no jungle. Extends, a class gives you the implementation banana gorilla jungle. That's exactly why program to an interface pairs with favor composition. Both are ways to avoid dragging the jungle. Dragging the jungle. Wanna go back? Wanna get back to slow device demo in a minute. Yes, both establish and is a relationship. So interface and like inheritance is a like providing us is a relationship. That's the unifying truth, and your own generics nodes already nail it. Interfaces are parents for polymorphism, instance of, and upcasting. Both are real parents. Wonderful. The proof is substitutability. You can upcast through either. Through either. So if dog extends animal, it means we can upcast to animal too. And since dog is comparable, all right, this is not upcast. I guess it's just that's interesting. So dog is a comparable via implement. So dog is instance of both animal and the comparable class too. Not class but interface. Both let a dog stand in for the supertype. That is a test. Let's go substitutability. And both pass it. The nuance, same is a different content. People sometimes phrase implements as a can do to highlight a difference, but it is still is a yeah at the type level. The real distinction is what you inherit, which ties straight back to Gorilla Jungle. So extends is all right. So type implementation state. So we fetch the jungle. All right. Fuse method bodies banana gorilla jungle. Implement type only the contract, no state, no bodies, just a banana shape promise. All right. So extends is a and inherit how it works. Implements is a and I promise to provide how it works. So we know that. Your own string proves it. Like a car sequence. High, like a string class instance of compare. Yeah. Also, instance of object because every object in Java is a child of object class. The clean summary. All right, so we know it. So ready to get back to do the slow deposit. Yes. So yes, scaffold to deposit demo. But before that, in our account controller, I try to create a method called slow deposit. Can you please check it before you start? And like, where should we position this slow deposit? Is the account controller correct place for that? Let's see. Oh my gosh. So now we're gonna create a method that works very slow. I guess another endpoint with fast, and we see the locking mechanism. We will try to do a write operation on a same object, I think, on a same record in our database, and we'll see that it is prohibited. So a composition is a floating class like serverless process. Then when you call it, it just copies itself and attaches it to your own. Then it processes stuff you pass through it, but you don't adapt it on your own code like using extend. It is just attaches. Yes. So There are two ways for you to be able to use a method from other classes. One is basically extending. If you extend, you suddenly become it and you can use methods of those classes. And the second way is basically creating an instance of it inside your class, which creates dependency, and by using the reference of that instance, you call that class's methods. So in object oriented, basically, let me so in object oriented, two ways to reach or to use a different class's methods. First one is extending, and this comes with a cost. And the second one is through via instance of that class. So these are two ways. Because if you, for example, create an instance like a class A, like a, let me, class A, new. Now you can call its public methods or, protected methods. Method 1, let's say. You are able to call it. And if you extend, if you class A extend, I mean you use class extend. So if your original class extends class A, then you can use class A's method too. So this is first way and this is second way. Account controller is the right place. Your reasoning checks out. Slow deposit is a single account operation, so it belongs with the other account endpoints, and it stays a thin adapter. Parse call service map. Positioning is correct. The endpoint shape is correct, so it seems correct. One thing to fix. Line 61 calls account service withdraw. Yes. Copy paste leftover. The controller must stay dumb. No sleep here. So it should call a new. So in account service, we need a method called slow deposit apparently. Do we have this method in no demo? Oh yeah, we have it. So basically, it's I guess sleep not 2 seconds, maybe 2 seconds, right? Or two. If it is, let's see, milliseconds. What is the meaning of 2000 milliseconds? 2 seconds? Most probably 2 seconds. So it will basically make like it will wait that line when called. So we should call slow deposit method over here. All right. And as this method runs, this will cost 2 seconds basically. Yeah. So now we should try a write operation on the same account. So that we see concurrency. The sleep window lives in the service. Inside transactional, that's the critical bit from the timeline. Let me scaffold, alright. This 2 second sleep window already placed between load and mutate. That's the boilerplate. The placement is the whole trick. two to-dos for you, both identical to your deposit. Step 1, load the account by ID. Load the account. So we have our first to-do here. Load the account. So we, like in our service class, we have the reference to our repository, which is let's see, let's find its name. Account repository. Like I tried, but I didn't see. So account repository and find by ID. All right. This returns optional account, which is interesting. Let me also take a screenshot of this and paste over here. So find by ID. No, what was it? Throw something like, let's copy paste from others. Or as throw, not no. Let's type it. Or else throw, and it was taking an function, right? And that function was returning an error, but what kind of error was that? Account not found. Account not. But I wonder. So guys, this exception should come from. Come on! Oh my gosh, we don't have it. So where exactly? So all right. So in the same package we have it. All right. All right. So since it is in the same package, we don't need to import it basically. So this is the custom exception that we have created. So all right. Because at first I didn't see it, but it was here. So we created that custom exception, and now like new throw like this one, or new, and I guess like this, like creating an object, because it's a class. And also we share the ID because it takes an ID. Why does it need an ID? Account not found ID. All right, it needs it. It needs it. So share the ID to, I guess, ID and semicolon. So we try to like we are trying to find so that account, and this method returns an account if there is one. If there is none, it returns what it returns to be to actually. So this method returns, return type is, I don't know, is it T, and T's type is classes that are child of throwable, and interesting. All right, let me take a quick screenshot. So it throws an error or return value. If there is a value, which value are we talking about? This value should come from the class itself. Let's go back up. Yes, we have private T value. All right. Oh my gosh. Anyway, I wanted to see it returns an account, but account is one of its abilities. It can return anything. Like, so like this returns an optional, right? Optional account basically. So when we open this, when we open this, for us, like, we are able to call this method via the reference of this. So what does it return? It returns an optional. It returns an optional t. So that optional account should be extending. No, no. To understand how we call this, how we call this or as throw, is to look at the definition of the class, which is optional. All right, of course, of course, of course. Like, I should have guessed that. I should have guessed that. Um, like, because otherwise we wouldn't be able to call this. So this method belongs optional t, and this is optional account. Since optional account is kind of like a variant of optional t, we are able to call this. Oh my gosh, wonderful. So this is optional t object instance, to be more precise. Optional t instance, and we call this, and it returns an account. Load the account by id. So yeah, so return 404. Yes, we are doing that. And where does it come from? We have this in our same package. What is our package? Account package. In account package, we have defined this exception which extends runtime. All right. Why is it important for this class to extend runtime? Is that open this method and look at what it gets. It gets an argument that extends x. All right. And what is, and x should extend throwable. So if we open that runtime, if we open that runtime exception, we're gonna see exception, and then at some level of chain we should see throwable and exception extends throwable. So this is our x. So exception is throwable, and runtime exception is throwable and exception. All right. And so if you like, so yes, so x should extend throwable. So like, this means that this method gets an argument that that is child or same or child of throwable. All right. Now what? Now what? Now we are in this. We are in this together. So we have an account. So demo window, do not remove until the race is seen. So we get our, so step one, load the account by ID. So like, I really like this or as throw method, although it seems kind of ugly, to be honest. Like, it starts with or, and I don't like the letter O and S. Like, find by ID looks kind of cool, like it contains ID and find, but this is something like, but the way, like, the way it works, it functions basically, is good. All right, because the argument it takes, actually it is also interesting that we just yeah, just as through. So like, here the thing we see is just an argument, that is like extending, that is child of X basically. Here, all right. Like we are passing a function that returns this one. So actually we don't pass like a new account not found exception. So we don't pass runtime exception. We don't pass exception. We don't pass throwable. But instead, we pass a function that returns account not exception. A function that returns exception. A function that returns throwable. Why? Why? And also, how are we supposed to see this can be a function? What is supplier? Supplier is an interface too. And it is functional interface, by the way, guys. So can we look at functional interface? Yes. I sense rabbit hole here, Americano. What do you say? We have an interface annotation that is strange. Functional interfaces. Yes. I say we no. We shouldn't. We should complete our service class. No, don't say that. Take it back. Take it back. Come on. Like uh like we can search these later, guys, like documented and retention, like what is this interface, element type. Dive in and search for accounts. Not today, man. Not today. don't don't make me do that. Don't make me do that. So like we have like I really wonder what sort of thing is that, like these are annotations and this is like, oh my gosh, Java Lang annotation package, oh my gosh, indicates the context in which an annotation. All right, I'll head. Whatever. So like let's complete our goal first, and then if we have a time, let's do this. Okay, all right, that will be logical because um uh I wanna continue. I mean I wanna build something like a real in this project first. I wanna see it working basically. So we have account servers here, all right. Uh, we have we have so we have magical method or as throw that takes a function as a parameter and returns that. Amazing. We have our account. So step 3 is add amount to the balance, return the account. So add so for to add a balance to account, we should use like add method from that big decimal class, and we can copy from deposit basically. Account set balance. So this is the way how we do it, guys. So I guess just below this one we have amount. So account.get balance returns big decimal. Big decimal class has add method. We basically add it. Do we try, like, are we gonna try saving it into our database? Then fix the controller. Point it at alright, so now that we have slow deposit in our service, in our controller class, we already use slow deposit. So I guess we have like I have changed it earlier. Type those three small so check the service and um, controller class again and judged. Let's see. Let's see. So now we are familiar with creating service classes. We are familiar with using or as throw, which takes optional type, and then return that object basically, which is awesome. Like we are familiar with creating service methods. In service methods, we use repository class to read and write our database. We are familiar with creating controller and using some annotations there. We are familiar with creating our own custom exceptions that extends runtime exception, that extends exception, that extends so throwable, that extends object. Or were they in implementing? But I guess they were um, they were extending. Yes, throwable and throwable implements serializable. All right, so now endpoint is serializable interface and object class. That is awesome. That is awesome. Um, let's see what we have done wrong. Controller, yeah, the service has one back. Oh, so I guess we have just forgotten to remove that one because our we just should return that one and save it. I didn't look at that part. So to do 3, you type the amount to do balance, then return the account. No save. Dirty checking flashes the update. I didn't understand that part, but we can ask it. Replace once you return the loaded account. Um, let's check it. Fix it. Check account service again. One thing to reassure you, since you mutated before sleep instead of after, that's fine, leave it. The version check fires at commit, meaning method return, not at set balance. Set balance only marks the entity dirty. The actual update where version is issued when the transaction commits. So as long as both requests commit after the window, the race happens regardless of whether you mutated before or after. I am half percent, 50% understanding it. Um, so just line fix it, Albert. So I guess somehow like, but we should like this is currently we are making our account dirty, meaning that it needs committing. We sleep 2 seconds. We sleep for 2 seconds, and then still we don't do any database operations. Basically. So I let's see. I guess we're gonna use this service method and the other one on the same account and see if we can hit concurrency. But let's see. The race fired exactly as designed. Really? The slow deposit demo has served its purpose. Oh my gosh. How? Raised observe the why and 409 proven. How, guys? How do you want to handle it before committing? Like, Let's see. Handler is permanent, but slow deposit is demo. Let's see. The race file exactly as designed. Thank you for good explanation, but I didn't understand, especially the part where you said that. I mean, first of all, why don't we like save to our database in our demo slow deposit? And how are we exactly trying to hit concurrency? Are we using other like a real account service method as well as this deposit on the same account, um but like slow deposit only reads, and we use set balance, but that set balance doesn't mean anything because it is just in our heap or something, so we don't save it to our database or something, right? So um, the important thing here is just reading. And like how did you exactly design this concurrency, um, let's say gameplay, gameplay, all right? How can you please clarify on that? Like AI has already tested our code and said we hit the concurrency, but I didn't understand the design of this concurrence issue. Like we only have this slow deposit endpoint, but so what? This is the code, but I need to see the call strategy, calling strategy, the execution of this basically. Great questions. There are there are three misconceptions, not one, not two, but three, guys. We are so lucky. We are so lucky. Be positive. There are three misconceptions tangled together. Let me pull them apart because the answer to all three is the same mechanism you already learned in phase one, dirty checking. All right. Misconception one: we don't save, so set balance is just heap and means nothing. Yes, so yes. This is the big one and it's wrong. Ah, uh, sorry guys. Like the set balance, like I didn't like this is controller. When you look at the set balance, yeah, yeah, it's just a value in our heap. No, I am right. I am right. Why? Means everything. Here's why. When you find by ID inside transactional method, the return account is managed entity. Hibernates persistence. Guys, we are living in Alice Wonderland. All right. The moment we read this account, it looks. I mean, it snapshots the fields of account so that during that time, if someone else makes a change on any of our fields, we basically prohibit completing this transaction basically. So this is the part where in popular e-commerce websites you add an item into your cart, and when you click on buy button, it says there is no item left available, something like that, all right, because someone has already changed it. So for that button to recognize that change, like that item you put is changed, is literally this: is is about this transactional thing basically. And this is the time went uh, between the moment you add the item into your cart and the other person bought it already and you click on that button again. So this is the time that goes by basically. Like, I mean, it represents, it simulates, it shows that moment. All right. And this return statement, although we don't have any write operation on our data on our database, we actually don't need to have one. Why? Because the beauty of this function is, like as I said before, like we are living in Alice's Wonderland basically. Why? Because this is magical and transactional. um, sorry for my cold jokes, but I don't know if it's a joke, but or anyway or not. This annotation basically gets triggered upon return. Basically, upon jokes are fire. Thank you, thank you, thank you. So the thing is, as far as I guess, like transactional annotation gets fired as my jokes are. I mean, like the time it gets fired is basically the return. So everything between here, like the in body, basically is protected. All right. So the magic lies here, guys. Like I wanna met someone. Like I met that person that who wrote the implementation of this beautiful annotation, because like we are the one who just try to understand how to use it, but the implementation detail of this protected body, I mean method body, is something real, man. Like let like oh, I think we can see that magical thing. Like, is this magic? Is this dark magic? Like this doesn't look that that magical. Uh, let's see. We can ask AI about this class because I expect something. Oh, he speaks. Hi, King Torby. Welcome in, King Torby. How are you? How are you doing, man? How are you doing? Selam aleyküm Habib. Esselamu aleyküm. How are you doing? Um, Ve aleyküm selam. Um, so like let's copy this part. I'm good. I'm doing great too. Thank you. Thank you for asking. We are studying um, Java Spring Boot, and we are edge of rabbit hole, but we wanna understand um, the implementation of this transactional annotation, basically. All right. Yeah. Yes. Letters and symbols. Yeah. So like everything is easy, man. Letters and symbols. That's all. You got it right. You got it right. And some combinations of them. Some random. so, um, so my question is that like before we continue, the thing we wonder is like this transaction annotation seems so powerful and so brave and so um smart because like it understands our object, which is account, which also can be other types too. In our case it is account, and it understands if a field of this account has been changed by other code, other stuff. So this requires some real coding. So I wonder how can we find the implementation of this annotation basically. Is it possible for us to find it? Or I mean, I click on that annotation and the thing I see is this class, but like it doesn't have lots of complicated numbers and some weird, like it has weird stuff basically. Like it has some other annotations like target, retention, inherited, documented, reflective. Uh, but I mean, I don't feel like I see some sort of lead code style implementation of complex logic. Why is that? Let's see, guys. Let's see. Without going deep, I mean, into the rabbit hole, I just wanna see who wrote this um, annotation basically, because it is good. Like you can give your account, you can give your transfer object if it was one. You can give your kinesin object, like any object, and also it understands if it has some changed field when you upon you return basic upon your transaction finishes. So like that is awesome, guys. That is awesome. Like I really wonder like how does it work. So this one of the best questions you can ask. Thank you. Oh, functional interface is a simple thing. It's not that deep. Just shallow click. That's interesting. That's interesting. All right, all right. I finally understand annotation. Annotations are like some stuff that boosts you, power ups you. You know, you add it and suddenly, like a dark magic or something, your method becomes so strong that can handle complex jobs. Like this is how I interpret it basically. But they are basically, because look at your account controller, man. Like there are like look at this annotation. Like we don't write really, like we don't really, like we don't like literally write how to behave when a post method comes, because it has its own. Open it. No, no, you cannot make me do it, man. We are already in a one rabbit hole. We cannot inside two rabbit holes at the same time. Come on. Just wait a second, alright? Wait a second. We are now like trying to understand who wrote transaction and how it is working, you know. My brother, you are saying words, but I have no idea what you are saying. I I illiterate when it comes to coding if it wasn't obvious. So no worry, man. So like we are learning too basically, and like I spent lots of time on this, so it's my job basically. So this should seem easy to me and like letters and symbols to you. So it's quite understandable. Don't worry, don't worry. So this is one of the best questions you can ask about Java, because the answer reframes what an annotation is. Short version: an annotation contains no logic by design. Guys, it's a label and the logic lives in whatever reads the label. Alright, so there is logic somewhere, but not in. Alright, that's understandable. So that's why when we open transactional label, we didn't see the logic, because that logic is in somewhere else. Annotation is metadata, not the code. All right, so the question now is, where can we find the logic? That interface file you are staring at does exactly one thing. All right, so we get it. Yeah. Where is the implementation? That's why interface no. Yeah. Where the real code actually is for transaction, the engine is Spring's infrastructure. These are the classes with the real logic. So yes, where can we reach it? Transaction interceptor, the heart Its invoke wraps your method, begins transaction, call your code, commit on success, rollback on runtime exception. But according to my scientific calculations, with the data shown on the screen and factoring in the slope of the pineapple, as long as you calculate for the acute triangle of the symbols and take into effect the interface, I can confidently say that the mitochondria is the powerhouse of cell. So yeah, that's why I picked the kinesin. All right, this is um, a small engine works in our cells that carries some particles. All right. So I love kinesin too. So transaction interceptor, the hard. So yeah. So annotation transaction attribute source reads the transaction annotation of your method via reflection and turns it into config. Platform transaction manager, data source transaction manager actually talks to the DP. Connection, begin commit rollback. Fun fact: this is how the US actually no this um and the proxy ties it together. Remember from earlier. Spring wraps your account service being in a proxy. The proxy is what calls transaction interceptor before and after your real method. That's the brave smart machinery you are sensing. It's just not in the annotation file. Alright. The proxy guys. We've seen proxy now twice. The piece that makes it findable at runtime is retention runtime. I guess we have seen this retention, right? Yes, here. Retention class. Oh, I haven't realized like this runtime thing, but it has really big meaning, profound meaning. Look at the metadata annotation on the annotation itself, the critical one. So retention runtime means the label is kept in the class file and readable while the program runs via reflection. That's the only reason Spring's interceptor can find your transaction at runtime and act on it. Override retention source thrown away after compiling. The compiler reads it once. Compi post mapping. Post mapping. Where is post mapping? And what is post mapping? Is yes, this one. All right. So, what about it? Like, do you want me to like open this one? Like, post mapping is also it is also runtime. I dug deep. I don't want to anymore. So uh, like the thing I wanna see, guys, is that engine stuff. All right, that engine, the hard stuff. Like I wanna see that thing because most of the time they encapsulate that valuable code from you so that you don't see it, right? If it is not open source. Mechanism. Transactional, the boundary when to begin, commit, and roll back. Hibernate persist, noticing you said it, understands if a field of account change. So careful. Mechanism, this, the boundary, begin, commit, rollback. Hibernate persistence context, noticing your set balance change and manage entity and emitting the update at flash, guys. This is Hibernate doing it for us. So this is I think this is the engine. Transaction just decides when the transaction commits. At that commit, Hibernate session does, oh, this account is dirty. Update part. The version check writes on Hibernate update. Understand. Oh my gosh. Understand the object. Hibernate, transaction binder, Spring. So they are partners, not the same engine. So general pattern, annotation, declarative markers. So we declarative. Like we are adding declarative markers basically. Like these annotations are declarative markers. Annotations are declarative. The declarative marker, guys. A separate processor. Imperative logic that reads the market. Alright. So and acts on it. Um, in every row, the annotation file itself is a near empty interface. In every row, the brains are always in the reader. Cross language anchor. So C sharp transaction style attributes. Identical idea, pure metadata read by reflection. I've, I've heard this term in Unity Engine 2. Like, this is about engines, guys. Unity's game engine, Spring Boot, like a e-commerce engine, I don't know. It's near empty since the compiler knows how to handle it already. Basically, they just omitted some of the annotations since they coded how to handle it on the compiler directly. It's near so annotation is near empty since the compiler knows how to handle it already. Basically, they just omitted some of the annotations since they coded. Yeah, I think kinda right, because actually the role of these annotations, like they are completing. I mean, they do their job. Their job is just like think annotations as like config files, like config file that includes some flags. Should we do this? Yes. Should we do this? No. Should we do this? Yes. Yes, no, yes, no, yes, no. So we put it, and the reader, which is engine, reads this config file and acts on it. So the logic part is on the read place, read component, not here. Only stacking annotations like post mapping has 1-2 definition. So like, as far as I understand, annotations are like a config files, nothing more than that. Annotations are just prevent you from making human mistakes. Example, functional interface just tells the compiler, hey, I have one abstract type. If the user hasn't defined it yet, scream at it and until it does. Yeah. Like this is kind of what I understand. Yes, yes. See, no real equivalent. Closest is pragma or name. Okay, so Python decorator looks similar, but it is different. A Python decorator is a function that actually wraps your at definition time, runtime, compile time, and definition time. It carries the logic itself. Java annotations carry no logic. They need an external reader. Worth knowing so you don't assume Java behaves like a Python. So they are different. All right. So you cannot find the implementation by clicking the annotation because by design there is none there. The implementation is in the reader. For transactional, open transaction interceptor. Alright, guys. Transceptor. Abstract platform transaction manager. I guess we can reach jargons. How beautiful. And transaction interceptor invoke, which is awesome. So you can see the begin, commit, and rollback skeleton, or get back to finishing task. So you cannot find implementation by clicking. Alright. So yeah. So let's click. How do we see them? Show me. Yes. How is it gonna manage to open this file? Let me file the actual Spring source on your machine. All right. Let's see. These sources Um, jar is right there. Let me extract the actual. Oh, all right. Invoke is thin. It just delegates to is the parent. So that's where the bacon comment Cicada lives. Let me pull. Let's see. There it is, the real engine. Strip away the reactive Kotlin branches edge cases. Oh. And the core skeleton is the exact shape. The real coding you said, the annotation was missing. Read the transactional metadata of the method reflection. Transaction attribute. Transaction attribute method target class. The thing that talks to the database. Begin. Open a transaction if needed. Create transaction if necessary. Alright. Transaction info. Object. Run your actual method. Oh, so this is slow method. Alright. Slow deposit. This is our method, guys. But where where was our method again? Here. Uh, slow deposit. Like oh, but it was about database. So this transactional annotation invocation proceed with invocation. All right, that's interesting. Commit on clean return. Read it against everything you have built this session. It's all there literally. Line in this method get transaction attribute. All right. We can we can check it later, guys. We can read it. We can read it, but later. Um. So now I think my last question was about um, how do we test these methods? And sleeping 2 seconds. Like, how do we? I mean, how transaction annotation understands that account has some fields that changed somewhere else other than us. So we need to understand this too. So the time, 2 hours. All right, 11. All right, all right. So after learning this, after we learn this, we can continue with the next task. I mean, because there's a reason why we did this, all right? I mean, there's a reason why we wait for 2 seconds. So we let other, like the other stuff that changes one of our fields. The crucial realization is, yeah, I know, come on. Nothing watches anything. There is no observer, no polling, no shared memory between two records. What? The detection is the side effect of one update statement and a row count. Like, yeah. So, do you mean that when we like make a query, like a read query, do we add something? Like, do we update or do we like which one? Like, I need to see like what changes the row count. Two transactions never see each other. Request 1 and request 2 each have their own session, own database connection, own in-memory copy of account 1. Alright. They are blind. Yes, I know. Request 2 has no idea. Yes, continue please. The database does. Hmm. At the moment request 2 tries to write, the only thing they share is the single physical row in the account table. The version column on that row, on that one row, is the entire communication channel. So guys, basically I think what we did is we basically tell our database, actually the reason why we have used that like a version thing. Yes. So we basically make, where is it again? We basically, guys, like this account is entity, right? So yes, so GPA talks, I think, with our DB and create a special um like a like a column, all right? And we tell our DB to, you know, take this version column, and so we basically we tell our DB to update that column basically, all right? The responsibility is on DB, but we are the one who tells it to do so. It doesn't. The database does at the moment. When, all right, so the next question is when this is happening exactly. At the moment request 2 tries to write, but the thing is, do we write in request 1 or do we do only read operation in request 1? This is important, guys. The only thing they share, yeah. So mechanism version goes into where, and the row count tells row count. When you loaded the account, Hibernate remembered the version it read. It's stored in your managed entities version field at commit. But the thing is, guys, uh, like I don't see any commit over here, guys. Do you see it? Do you see any commit? Please tell me. By commit, I mean, all right, guys. Now I see. Actually, like we change a field, and when we return it, we basically commit it, thanks to this annotation. But the thing is, guys, we don't. Oh, we do, guys. We do. Why didn't you tell me, guys? Come on. I've been I've been trying to understand this for almost 10 minutes or something, maybe even more. In this method, guys, atomic commit every set balance. Yes. So like we are right, like we do writing operation actually, to be honest, actually we change the field, and then as we return, in it translates into commit. So we basically do a write operation, and like we change the field, and before we commit this transaction into our database, we wait 2 seconds. So we have another request too, and it writes that field too, but it writes before us. So when the time comes for us to commit, then there is an issue. All right. So in our database, like our code generates an SQL query. For every 10 minutes it takes you to understand something, it takes like I'm familiar with Java and like a Spring Boot framework. Like I developed a few projects. Like it should be that way. So don't worry about it. Don't worry about it. It should be that way. Um, at commit, Hibernate builds update, like so. Hibernate builds SQL for us, for our DB actually, all right? And the query it generates is update account, set balance to this. Yes, so this is why like this line translates into this. So like this one means increment apparently. Like I would be happier if I see plus icon or something, but I guess in this query thing this means increment. Where id is id is one because yeah, so we have the reference of account, so it gets that id from there. And version so 0, but only if version is still what I loaded. All right, so the thing we need to understand from this is Hibernate generates an SQL for us to run, to make DB to run this query, and that end version 0 in the where is the whole game. No play 2 commits as 0. All right, so request 1 commits update, yeah, finds the row 1 row updated version now 1. So request 2 commits update where id 1, db finds no such row. All right, so basically our query handles it. All right, our query catches if the version is updated or not. So Hibernate then checks how many rows the updated affected. It turns that count Hibernate's logic is literally expects 1 row to change. Got 0, someone changed this row before me. Throw optimistic log established. So this is the exception that Spring throws us for us. Throw it for us. That's it. No magic understanding. The detection is easy. My version stamp update matched 0 rows. Therefore, the row moved. The database row level atomicity is the synchronization point. Row level atomicity is the synchronization point. 2 updates against the same. So now the another question is, guys. Now the question is that we depend on the synchronization of DB when a same account changed from multiple places. All right. But the thing is, like, I don't see concurrent. So I guess like there were some other concept like close to concurrency, right? What was that term? Because I thought concurrency is like in operating systems. Like we had a lecture where we literally try write or read any operation. But since I guess this issue occurs in multi-threaded systems, right? That the other concept that I'm talking about. So could you please clarify on that? Because in operating systems lecture, we had some locking mechanisms like semaphores and then some others, and I guess I like misunderstand this concurrence issue with that one. um all right, Americano, take care. Most probably I am gonna take a break. Oh my gosh, I'm gonna take a break soon too. I don't know when, but take care. I accidentally paste the message to the chat. All right. Take care. So now the question is that we depend on synchronization. Oh, yeah. Because I thought, yeah. Talking. All right. Um, could you please clarify on that? Actually, we have the full format because in that dictation we don't have. Anyway, copy this one and press enter. Let's see, guys. Please don't ban me in the mail. Alright. Alright. I'll try my best. I'll try my best. Americano. Let's see, let's see, let's see. You're not misunderstanding, you are connecting two views, the same thing, and missing the vocabulary is what will make it click. Yes, this is concurrency, the exact same family as operating system lecture. The term you are reaching for is race condition. Yes, and the reason it feels different is where the shared sources lives and which of the two strategies you use to protect it. It's concurrency, same problem, different medium. Operating lecture is operating system lecture. What runs concurrently? Threads in one process, so shared sources. Our wallet, separate transactions, separate threads, connections, maybe separate servers. Um, Shared resource, a variable in RAM, a row in the database. So we are comparing our wallet and your operating system. So the bug, race condition lost update and race condition lost update identical. So identical, same phenomenon. Two actors ready modify write a shared thing in overlapping time. Overlapping time. All right, all right, all right. And one clobbers the other. In operating system class, the shared thing was memory. Here is DB, like database row. The concept is the same, only the medium moved from RAM to disk. Yeah, two strategies. This is the vocabulary you are missing. Every concurrency problem is solved one of two ways. Pessimism, assume conflict, lock first. So this is the version I was telling. Basic, I remembered. Assume conflict, lock first, block others. This is your operating system lecture. Yes, semaphores, mutexes, synchronized. Before touching the resource, you acquire the lock. Everyone else waits. Mutual exclusion. The DB equivalent is select for update, a row lock. And so we have this locking mechanism in our database too, guys. That means this. And that's exactly what says we deliberately did not. Oh, we deliberately not. All right. Optimistic. Assume no conflict. Don't lock. Detect at the end and fail if you lost. No one blocks. Everyone proceeds freely. Proceeds freely. At commit, you check. Did the thing change under me? If yes, you fail and retry. That's version. No lock was ever held. The collision is detected after the fact by the version check. After the fact by the version check. The bridge to what you already know. Version is compare and swap. Here's the connection that will lock it lock it in. Your operating system architecture course had two tools, not one. Pessimistic in memory, pessimistic, optimistic, passive. Semaphore mutex, block others, what you remember. Optimistic in memory, the CPU compare and swap, atomic instruction. Write this new value only if the current value is equals what I read. Lock-free programming. In Java, atomic integer, compare and set, expected and new. We literally have the code for that. Version is literally compare and swap on database row. So the concept we have in our CPUs is exactly used, well, not exactly, but similarly used in database too. So that's why it's important to grasp the fundamentals of uh, fundamentals basically. We can apply it any topic. So CPU, compare and set expected old value and new value. Succeed only if memory still expected. All right. Same idea, different medium. So all right, I kind of get it. I kind of get it. So why we can't just use a Java mutex here? The punchline. So yeah. So it says that instead of like a getting and updating and mm, upon committing if there is an error rollback, if instead of doing that, why don't we just log immediately when we reach that record? This is the reason the synchronization must happen in DB, not in Java memory. Real apps run multiple server instances, horizontal scaling. Two Java virtual machines, two separate heaps, a Java synchronized block or semaphore only guards memory inside one Java virtual machine. So there's a reason why we have this locking mechanism. I mean, in DB size, a Java synchronized block or semaphore only guards memory inside one Java virtual machine. Server A's lock is invisible to server B. So in-memory lock cannot stop two servers from reaching on the same account. The only thing both servers share is the database. So the synchronization point has to be DB via either a raw lock. So we can do this like a pessimistic and optimistic version. We can do these two approaches on DB2. I thought differently before, but now I get it. That's um, That's why this isn't your textbook in process mutex problem. The shared state is removed. So I mean operating system primitive toolbox semaphore mutex doesn't reach it. The database level tools do. Oh yeah, the full map. Operating system CPU in memory semaphore mutex synchronize. Data in database select for update. And optimistic. Compare and swap and version in our code. But why don't we see the query version here? Like this is pessimistic, this is optimistic, this is CPU, and this is database. But instead of showing the optimistic version, so let me like this is like I'm gonna ask and then continue, right? Like in the right bottom row square, all right, you showed like a version what you built. So why didn't you show the database query? Because like I know pessimistic strategies database query type, but I don't see the optimistic query type in our database basically. Can you show it too? And before wrapping up everything, like I want these what we have already like studied, like different topics. All right, I want to have clear documentations about it so that next time I ask to you, so you can remember what we have studied during this development of this project. Um, so I need you to explain to me how do you test this actually. Like I know there is a request one and request two, all right. Um, but like so basically you are making two requests at the same time, but in another one you don't call slow deposit but normal deposit, I suppose. And since in our slow deposit we have like a 2 seconds delay, um, in the fast deposit you like in these deposit methods you give the same account. Since in the fast method it completes its right operation in our database, in our slow deposit method, when we try to commit, the database returns something saying that it is already changed, right? So we don't commit actually, and this is optimistic locking, right? So we can wrap up, guys, and let's see. We can wrap up and maybe start our new task. So now we have touched the concurrency part as well. So basically the solution is using this magical transactional annotation, and we also learned about the meaning of annotation. It is basically like a for me it is kind of config file where it tells engine, which is Hibernate, to how to behave on this method. All right, by talking to DB database, it handles this action uh, correctly in case something wrong happens. All right, the annotations don't have the implementation or the logic part, but only the label, the config. Like these are config files. Like this annotation makes our um, method powerful basically, but they don't have the implementation. All right, they have the rules basically. Two corrections and all in. Then I'll write the documentation you ask for, filling the empty cell, the optimistic SQL. So you're right, I showed annotation but not the query. Here are both strategies as real SQL side by side. So pessimistic is this. What we did not use. So I think they are same. So for example, select these fields from account where ID for update. So locks the row, other other attempts blocked. I think here, and then commit, and log is released. The log is held for the whole transaction. Anyone touching row, um, that row. Optimistic. So this is pessimistic. So optimistic version is select these fields from. So we basically no log, like we directly read what we have in our database at that moment. Compare and swap. This is interesting. And commit. Look anywhere if rows version is no longer zero rows update conflict, and this the cell that was blank, update where id and version loaded. The clean contrast pessimistic logs in the select, optimistic checks, pessimistic logs in the select, optimistic checks in the updates where. So basically we don't do anything with select basically in optimistic. We fetch the field, we do the operation. But the thing I don't understand is where do we exactly use update method? Is there a case where we use only select and not update? Like correcting your test mental model. Close but one detail off. Both requests called slow deposit, not one slow and one fast. We fired two parallel curls, both to slow deposit. So we literally made requests at this endpoint. Both loaded version 0 during their overlapping sleeps. Whichever commits first wins. The other gets 409. The two, the two sleeps are what guarantee both selects happen before either commit. The two sleeps are what guarantee or guarantees. Two sleeps, a guarantee is a name. The two sleeps are what guarantee both selects happen before. Like I didn't catch this part fully. That said, oh my gosh, your one slow one pest idea would also work and is arguably cleaner because the loser uh predictable. I don't get it. Your final summary, yes, correct. The fast method completes in database. So like if we use that slow deposit method, like same deposit method, why do we need to sleep 2 seconds? The fast method completes in the database. When the slow one tries to commit, the database says it's already changed, so we don't commit. This is optimistic looking, right? Exactly right on the mechanism. On one requirement of wording, the DB doesn't say it's already changed with a message. It just reports, alright, we are the interpreter. So uh, database basically returns raw information basically. I mean, not raw, but raw. Raw. I mean, because no row matches the old version. Hibernate interprets zero when I expected one as the conflict and throws. The DB is silent. The row count is the signal. Everything else you said is spot on. Uh, Documentation said it will survive. Now let's close out task 2. The code is done. The race is proven, but nothing is committed yet. Is permanent. My recommendation, remove the demo, commit the handler. Alright, let's do it and let's wrap up the what we have completed in this session. Alright. Like I need to exercise a bit. Let's see. Both removed. Let me compile and check what's actually changed versus back. Run like crazy. Welcome. Welcome back. Um, Account service shows modified. Let me check that div is clean. I want to commit only header. Alright. Welcome back, Americano. Now, like I'm trying to wrap up what we have like completed in this session, and then I want to start our next session, and then maybe take a 50 minutes break. It's been almost what it's been 2 hours and 30 minutes. It's been 8 hours since we are live. Perfect. just you, like just you have arrived. Now we are getting so like let's see. This session's commits. Yeah, you build complete 3-layer safety story for balance cards, rollback, version optimistic locking, and dug deep into why it works. Proxies, dirty checking, race conditions. Oh my gosh! You said you wanted to wrap up. Strong recommendation. Uh, you. It will write yes, a dated handoff and finalize the learning tracker. The next session likely. All right, let's run this. Let's have clean uh, working terrain. Um, Maybe in the next session we can do some lead code review or something. What do you say, Americano? Or maybe we should continue. I don't know. I don't know. Like I can, you know, review these. Lead code review is goodish. Yeah. Like we can go, a bit easy, but for example, this question. All right. So we can do this. We can do this. We can create animations. Um. All right. Let's see. Wait, how about CTF? Like, did you really see it? What is what is there was something called CTF right here among other concepts. Um, where was it? No, I thought you are trying to say CAS. So what does it CTF mean? What does CTF mean? Next session adaptive wear, adaptive replan. All right, commit the docs too. Wait, never mind. um, let's see what you have written here. While true, we are reading next line. So, like next line method is inside scanner, and it is no, it is not static. It takes instance. All right. It is slightly unrelated. So what is it? Tell me. What is it? All right. Adaptive. Let me copy this one, guys, and run clear. I like so. Anyway, remove that one and start a new one. And paste it. Relative pile. Let's see. The code is 2 meh. It's slightly under. Don't check it. It ain't good, but barely work. That's alright. That's alright. Like we have public method that returns nothing. Method for each loop. So like like I really need to have a cheat sheet for methods of hash map, like a returning keys, returning values, and like you are here return I mean cycling, iterating the keys of that hash map. And also we have learned that break loops the closest, the uh, nearest loop, right? When we are inside uh, multi-level loops, I mean nested loops, break um, goes out only the nearest. All right, so now we should run adaptive replan. Like today, I will try to end the stream at exactly 2 p.m. and because uh, I plan to stream and I just said give me commands with simple explanations now, please. AI is too open. Like I also want to create some new commands so that because like for example when we study leetcode you can run some commands in the chat and that can tell like can start a timer or something, all right, and maybe some commands that will generate some sound, so I can design some commands because we need to dedicate only 45 minutes for new question, nothing more than that. And also I want to make the streams you know fun and interactive way. So one shot phase 3 first slice actually locked down. Let's see. Clean baseline confirmed. Working tree is spotless. Oh my gosh. Phase 2 fully committed. Still holds. Now complete. This is the clean rollover. Rollover. What if add a shared editor on Arena? Yeah, I thought about it too, actually. I thought about um, like a maybe an input field here, and I can type like let's say compare to method. All right, I write compare to, and you can see and you can try to implement that code into your code. What if a shared editor arena so multiple people can work on a problem together, or make it like a Reddit, and but each thing like a live coding session you can interact. Yes. We can do that. We can do that. I have thought about it. It should be passable. It should be passable because the library I'm using is quite powerful, and the live editing should be passable too. Yeah. It will be fun because like it's called pair programming. So maybe I can say that Americano, I need to know how to iterate hash map, and you can find and you can type. And while you are doing that, I can think about the other part. All right. Mm, so like it would be great. Like maybe in today's study session, I am like I can handle this too. It can be fun. It will be fun. Maybe we can have like other friends and they can type their code too. Like it like fun idea. Yeah, definitely. We can do that. Like contains key. So this is storage, and storage is hash map, right? And that hash map gets string and array list. Look at it, man. Hash map and like contains key. So this is put. Yeah. So phase 3 security. Now we are adding security layer. Is the broadest phase yet. The ADR task depend on One decision, your nodes left open the shape of the first slice. Your open questions already leans toward in-memory user first, then layer JWT, which I agree with, but there is a fork inside the first slice worth pinning down before I write ADR. What should phase 3, first slice, actual lockdown, auth and ownership straight to GVT, auth only lock the API. Which one does it suggest? I think lock the API. What is the difference between these? What is the difference between these? Let's see. This is a sequencing decision about how to slice V3 security. Lock the API. Is this request from logged in user? Yes or no? The security filter chain being simply requires any authenticated principal for every endpoint. Anonymous request 401, unauthorized, authenticated request allow through. Full stop. So HTTP authorization request. No concept of who you are beyond. You are someone valid. So we can start with that. A logged in Alice can hit accounts bob transfer. Auth doesn't stop her. Smallest possible slice. One being one concern. Yeah. Auth and ownership. Are you logged in? And do you own the resources you are touching? Alright, so we can start with, of course, lock the API. Because we should start simple and then move into some other complex stuff. So again, it's been almost it is 20 past 12. Come on. Got it. Auth only for 3A, one clean lesson. How string intercepts a request and demands credentials. Oh my gosh. With ownership and GVT as their own layer slices. Writing the replan now. Amazing. So by the way, Americano, like, is the frequency of map is good or bad? Like, how frequent do you see it? It should be 2 in 1 hour or something like that. Let's see. So we have our account package. Only one earlier at the start. That's interesting. We have account package. Once again, I might have missed some of them. That's interesting. Account package, transfer package. We have our server, and we like the all important thing is that, guys, we realize that we cannot use account servers as a composition in our transfer servers, because account service is depending on an interface. So if we want to use account service, we also should instantiate that dependency too. All right. So the slice decomposes cleanly. 3A authentication. This replan, GVT ownership. Each one isolated lesson. Task 1 is deliberately tiny, so the dependency alone changed everything. Bit length before you write any security code. Task 2 is a real logic, security filter chain, in-memory user, be crypt. Task 3, permittal ordering, only if the first two go fast. Tip, run adaptive build to start. Alright, so we can run it. Let's see. We can run it and we can even color it. Let's see. See, senor. Mexico. Add it. Then boot with first move. You already added 4 starters to this Spring Boot security starter follows identical shape as security boot start web. Add it to dependency block. Add it, then boot with and tell me. Alright, so we can continue. So now guys, we can take a break. It's been almost 3 hours. We can take like a maybe 50 minutes break, right? Or maybe 45, I don't know. See you after the break, guys. All right, let me take a 45 minutes break and also decrease the sound. All right, see you after the break. Now it's break time. Hello. Welcome back, guys. We are back. Now, you guessed it right. We're gonna continue with lead code. And which question? Uh, find all subsets. Why? Because I wanna review uh like all this. Like I want all of these questions fresh in my mind, and like these first couple of them, like I remember, but this one I guess I don't remember fully. So we're gonna try solving this, all right? And it says it's backtracking. Welcome, 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 welcome. The topic now is, guys, find all subsets backtracking. All right. Our topic is now this. So what the question asked? Let's find all subsets. Should be easy, guys. Should be easy. Subsets. Subsets. So let's first check the question, I think, but we don't have the definition. Basically, imagine we have 1, 2, 3, and 4. All right. We should have 2 to the power 4 number of subsets, right? The first subset is 1. The second is 2, 3, and 4. And 1, 2, 1, 3, and 1, 4. So the order does not matter, I think. So I think 2, 1 is same as this one, right? 1, 4. And we can, 2, 3, 2, 4, I think. 2, 4. And 3, 4. All right, these are 2. So now uh, with 3 elements. 1, 2, 3. 1, 2, 3. And 2, 3, 4, I think. 2, 3, 4. And I think empty, like, do we need to count the empty subset or not? I don't know. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12. So, like, I think first it would be great if we check the definition of the problem. Subset, find all leetcode, because knowing the question is the first step. So, subsets. A subset of an array is selection of elements, possibly none of selection. So for 3 element, do we have 8? 1, 2, 3, 4, 5, 6, 7, 8. Yes, so I think I missed 1, 2, 3, 4. 1, 2. So the order, like, I mean, yeah, so we don't include 2, 1 here again. So this is important. So we don't include, like, when we come here, we don't, um, take into account the previous ones. All right, we kinda um, process what is on the right from the start point. All right, all right, all right, all right. So we need to design a decision tree, some sort of decision tree that will allows us to do this, guys. Like, I'll solve this question before, and now I want to remember, like a review. All right. So let's focus on the given example instead of trying to write type 16 cases. Actually, this is 3, and we can have one, like a with 4 number of elements. one with 0 element. I mean, not so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We need to have two more, but that's all right. Let's focus on this example. Let's don't lose any time. So we need a structure like a decision. So we need to analyze this very well to understand what kind of recursion and for loop we need basically. All right, let me make this full screen. All right, so like imagine, so what are our options here? So where do we start? What do we have here? Do we have 1, 2, 3 or empty? And I guess in each level we should like we can choose one. I mean 1, 2, 3 or all right. We can pick 1, 2 or 3, right? And then in the other one, like let's see what happens if our options are 1, 2, 3 in each step. 1, 2, 3, and here let's say again 1, 2, 3, and again. All right, let's see what happens. This is a way to start 1, 2, 3. If we do that, and if we let's say we pick this, and then this would mean like a this one. So we need to find a way to not process. So we need to basically decrease our search space, or shrunk or decrease shrunk our easy. Oh my god, I can write that. Decision tree. So like after picking one, we can, oh, you just got the question. So like subset problem, subsets. This is backtracking, and I remember I didn't understand the decision part of this question basically. And let's see. So like first we need to find how our decision tree would look like, should look like. Like imagine we pick one, and then what we can pick, two, we can pick two, we can pick three, and we can pick 2 and 3. So I think I would have to, I need to draw this up. 1, 2, and then after 1, 2, what we pick? So like should we like, is this 1, 2 and 3, or 1 and 2, 3? So this is one question I have. So 1, 2, 3, and another question is that should we save our decision right after we make a choice? Like these are choices, all right? Like 1, 2. So these are choices. In DP problem, backtracking problem, and graph problems too, the way we should think is like what are our choices? What our choices are? We need to determine this. We need these elements basically. So it appears to me that we should save, like as we make a call, make a choice, we should save it right away. So imagine we have a function, all right, and let's say it makes a choice, like make a choice. So this is a choice. It's making choice. So we can think of it like post order. I love post order. So we make a choice, and but this call means this call means an answer. I mean, when that method returns, it should have covered or discovered or explored all the things. All right. So let me think pre-order wise too, and let's see, do we have something? Imagine we are 32. Do we need something from our parent? Why is the first output empty instead of index 0 value? You mean this one? Root? Like this is root, and this is our starting point. And in our case, maybe we can imagine this as a empty 2. Like this is our start point. And actually, yeah, because when we call our recursive function, we're gonna call it with empty, right? So we can, yeah, if you mean this, Americano. So like, I try to think as pre-order. Oh, got it. So like, does 2 need any information from its parent? Actually, yes. Which information? Which element it has, basically. So like here, before the calling recursive call, this is base or phase or area for pre-order before calling. So this is pre-order part. Do we actually? Most probably yes, guys. Here we have pre-order too, because imagine our parent has 1 in it. Yeah. If our parent, so do we need to calculate anything here before the recursive call? Do we need to do anything? Like this is our one stack frame. In one stack frame, we have 1 inside ourselves, and let's suppose we need to explore 2 and 3. All right. So for each loop, so maybe I can move this one over here, and let's say we need to process 2 and 3. So here maybe we can append let's say current, we can append like this iterator current to this one. I mean, like, currently it is not func but for, sorry about it, guys. Like for each, and func is outside of it. Like our call stack frame is this one, and also let me move it here. Because we should like iterate through all of our options. Like step 1, determine our options, determine our decision tree. Like this is one, but I didn't complete it fully. But let's suppose we have these options. Now I want to think about what should I do pre-orderly before calling. Before calling, like we should like actually we don't need anything from our parent. Like only thing we need is like this what it has, and we will add um add us add yes add 2 for example. Does this count as pre-order? Is it pre-order? All right, is it pre-order? Let's say we append, and then we call recursively with um 1 and 2, I guess, right? 1 and 2 now. All right. And in backtracking also we have something like post order, like after this function return. This is post order part. What we need to do in post order, like to answer all of these guys, like we should draw the decision tree very well. Let's draw it again because it may fail. All right, so we have this. Our options are 1, 2, 3. After taking 1, what are our options? After taking 1, what are our options? We can pick 2. I mean, we can pick 2 and 3 actually. Like, don't look at the output. Look at our choices. After picking 1, our options are 2 and 3. So after picking 1, our options are pick 3 or 2. After picking 1 and 2, our only option is picking 3. After taking 1 and 3, it is 2. Or is it? Or is it? Let's see. After taking 2, guys, I think this is the where we avoid duplication. So if we pick 1 and 3, our options, like we don't have any options left. After we pick 2, our options are only 3, and after picking 3, we don't have any option. So we pick 1, we can pick 2 or 3. After picking 1 and 2, we can pick 3. If we pick 3, we can pick nothing. All right. Like if this is our decision tree, guys. Now what should we do? Like, first of all, to be completely honest, I'm not really thinking of the process. I think I'm focusing too much on the output as a guide. That's why I'm having trouble full internally. So this is advanced topic actually. You should internalize recursion very well. Although I see myself internalize recursion like a post order and a pre-order very much, and I have solved lots of tree problems. Still, like a still I'm not 100%. Like, for example, I need to make sure that this decision tree will give me this actually. All right, let's see. We pick 1. So we pick 1 and save. So the pre-order part with this is, as we as we call like a pre-orderly, we save this as an answer. So this is our pre-order part. This is 1, and we save. Like we save 1 as a solution, and as we come here, we save 1 and 2. When we come here, we say 1, 2, 3. This is because we use pre-order 2. So like this is 1, because there are some decision trees where answer is not on the way down, like during the path traversal, but only on the leaf. So there are some questions that the answer is only these, but here we should like like we can get answer if we save the result while we are calling, or yeah, upon we call. So like 1 1 2 1 3, and let's say like this is 2, this is 2 and 3, and this is 3, and this is 1 and 3. Do we have do we have all answers, guys? Do we have it? 1 2 3 4 5 6 7, and if we count empty 2, 8. How, like 1 1 2 3 4 5 6 7 8. I guess we got it right. We got this, we got this. So yeah, so this is the pre-order part. All right, as we come here, we immediately save this as an example. What it means, guys, is this one. All right, this is advanced topic Americano. This is like I've spent a lot of time before this. So the prerequisites to understand this question is recursion, and then tree. Yes, at this recursion and tree. All right. So let's see. Um. So all right. So let's imagine a function, and like we call, and but we save it. So imagine a recursive function that makes other calls, and we have a for loop, and we make our recursive call over here. All right. So like I'm trying to understand the pre-order part exactly. Like because pre-order, like for example, you are 2, and what do you need from your parent? Actually, like after drawing this decision tree, we made sure that if we save these, this gives us the answer. So we can then we can like therefore uh, we can focus on now pre-order, because we first thing we should do is making sure that this decision tree provides us a solution. All right, and so from perspective of this child, all right, what does this child need from its parent? It needs obviously this one, I mean this list. All right, because it will append on it, it will append that list. So before calling our function, we need to or here it doesn't matter, we need to mm, let's say, let's suppose this is 1. All right, let's suppose this is 1, this is 1 stack frame. We need to append, we need some sort of list. We need to append that list with what parent has. What does parent have right now? Where do we hold this information? Actually, for like in pre-order, we share knowledge via argument. Um, but now the question is, should I see from perspective of this one or this one? If I am child and if this is parent, parent should give me this one as an argument. All right. So I need to have like a one as an argument if this is one. But uh, let's see. Forget about for loop for a second, all right? Like we have our function and again function, all right? So like 1 and 1 2, 1 and 1 1 and 1 2, 1 and 2 3, 2 3. So I learned that for period order I need to assume myself as 2. Oh, I think I sort of get your perspective now. You are thinking from start and looking at your moves. Actually makes a lot of sense. Yeah. So each node here is a decision and is a recursive call. So this is a recursive call, this is a recursive call, this is a recursive call. So I designed my decision tree and I said that like as I go down, if I save the value I have in each step, like these give me the result, so that now it is time for me to code this, translate this decision tree into code. All right, this code has like a pre-order and post-order uh, parts. So now I'm thinking pre-order. Holy, that actually makes a lot of sense. Like especially if you don't have a sample output. Yes, like the best thing you can do in like a recursion, forget about like focusing on output. I mean, what we create, like with only single output you can design, all right? You don't need lots of example outputs. um like recursion is kinda magic. Like now I think pre-orderly, and I like from perspective of child, like I learned that I should see myself as this one and what I need from my parent. But I forgot how am I supposed to like how should I see myself like in here? Is 2 is here this one or this one? All right. I suppose Funk is like a 1, all right? And this one like is child and it should get 1 as an argument. Oh, I need to apply this constantly. This is actually a very nice way to solve. Like this is the best approach I could come up with, all right? I tried lots of things. Recursion is hard. Even its basic questions like is hard are hard. So let's say this is one's stack frame. We have in one stack frame. What do we have actually? Um, what do you what do I mean by one stack frame? In one stack frame, where um where like a current list, we need something like a current list. Uh, and what I mean by stack frame of one is like when the current list is one. Let's say the parameter current list is one. All right, here we should give this current list, actually we don't give this current list as parameter, but we append it. All right, current list dot append with what? With 2. For 2, then this means that this should be inside the for loop. All right. So because otherwise we cannot reach. So we need, guys, we need a for loop. We need a for loop. All right. Like that smart for loop that will give us 2 and 3. All right. Let's see 2 and 3. And let's suppose we can think about it later. Like think about how it can generate 2 and 3 later. The focus should be what will we do when we iterate 2. We should append it the current list that, like, but this is not pre-order. I actually, this is pre-order, but like this isn't something our parent gives us, but actually yes it is. We get this list as an argument. Argument means we get it from our parents. So from our parent, guys, we get 1, and also from here we get 1. All right, so current list append 2, so we should append it. And so I think the way I slightly understood wrong is that, like, using an argument from your ancestor doesn't mean you have to add it, like use it as it is. Of course, like you don't have to do that. So but now the blurry part is that, is this function a stack frame of 1? And if it is, like if it is stack frame of 1, then is 1 parent? Because this is us. This is like, now I need to clarify the meaning of parent and child in terms that you using term of stack frame. When 1 is the parameter argument, are we in stack frame of 1? What does stack frame mean? Amazing. So stack frame means, this is about actually recursion, the essential, the foundational part of recursion. So imagine you have a function and it takes an argument n, and what it does is use as argument and calls n minus 1. All right, return a minus 1. So when you call this function with, like, this is the code, and when you call this function, let's say with 5, so stack frame really means your stack, actually in your stack. So let's say in Java main, all right, you call your function like this. The things you're gonna see in your stack is like a integer 5. This is stack frame of this call, this function call. And then the next stack frame will be like this function 5 is gonna call what? 5 plus func 4, right? So this func 4 is this one. All right. And this func 4 is gonna call what? You guess it right. Func 3. All right. So current state after recursion step. Yeah. All right. These are your stack frames. Stack frames is for representing each of your recursive calls. Func 5, func 4, func 3. These are your function calls, and each has its own values. I mean, value by values, I mean, look at, like, this is 3. Because look at, like, look at this. Our function is func n, and here n is 3. Like, imagine this as a parallel world, parallel universe. In this universe, n is 3. In this universe, n is 4. In this universe, n is 5. And the relationship between these is when they return, like, imagine, like, when they return, all right, actually, like, look at this. When this returns, you get its value, all right, and add what you have. What you have, what you have is n. You add n to what your next call returns. So basically, imagine func3, all right, returns you, let's say, x, all right. What you do is add your value on top of the return value of func3 x, all right. So you got your value. Now, what func4 will return? It will return, I mean, this value. So this what will 5 do is it will add itself on top of the return value of this one, which is 4 plus x. Stack frame. And so how many recursion loops? Or yeah, kind of, yes. So there is a term, stack overflow, as you know. This is the reason, like, if you write a code that opens like a bunch of tons of billions of stack frame, all right, so it calls this again, calls this again, and if you didn't set your base case correctly, and if it creates lots of stack frames, then I guess some part of your memory gets very full and gets some error. Oh, so this is what yes. This is what it means. This is what it means. I think there are some other overflow parts too, but this is one of them, I suppose. In one of my midterm or final exams, in the questions, we need to explain the overflow types deeply. So I guess this is one of them. So in each stack, what you hold is parameters of your function. Like, stack frame holds your parameters and, like, everything related to your function. All right, I think. All right, this is stack frame. And so where were we again? So the question is, like, if we say that we are one, can we see it as a parent, and can we see the call that it makes as a child? Most probably yes. And this is the way for one to be parent, actually. Like, when this is parent, it is in here again. Like, I guess the reason why I couldn't really, like, immediately. Oh my gosh, so, oh my gosh, we have 7 minutes left, Americano. 7 minutes left, so we need to rush. So this is parent, all right, this is parent one, and we should append it. So the value, the argument coming from our parent is this. So this is pre-order, all right, pre, and we append it. Oh my gosh. So what would happen if we give that as an argument to our children? But this is one, and for our children we make, like, we give 1 2. So, like, this is us. And while, like, before we call basically this, we append it, and we make this call actually not with 3, but actually with 1 and 2. So actually, like, it can be like this. 2 can be the option, but it also represents our um our stack frame, right? In this stack frame, our current list will be 1 2, and in this one our stack frame should be 1 3. All right, for that, like 1 3. So um and now let's suppose what would happen when this returns. Let's like when it returns, it still has 1 2, and now we're gonna call and we're gonna append with 3. All right, if we have 1 2 in our argument, so if one gives like a 1 2 still to this, then we're not gonna be 1 3 but 1 2 and 3. So what I am trying to get is we should like as we return, like as this function returns, after it returns, we should remove append. Do we have something remove last? Let me say. All right, remove last index, so basically we have solved this question. Like the important thing is like the one of the most important step here is being able to draw the decision tree, because this is quite important, because we said that while we going down we should add like here we append our option into our list and then make a call. All right, we append. So this is why this is pre-order. Solved it 3 minutes later. Yeah. So like I can keep talking about this for a long time, but since I want to make another stream today, I wanna rest more. Like this is hard, this is quite hard, but I think if I solve recursion problems with pre-order heavy, then it will both help greedy problems, because I've seen a lot of greedy problems that work like a pre-order because there is something coming like a running sum. All right, how many hours from now is the next? I no, you should sleep. I don't know, maybe 4 5. I don't know. Like I really wanna rest. Maybe 6 p.m, maybe 7 p.m. I'm not sure, maybe 8. Like we'll see. Today will be the first day, so we'll see. I need to exercise, I need to walk, you know so I think the thing I should do is, guys, like solving lots of pre-order questions. All right, I'll set alarm for not 4, like a 4 5. Like this is now 2 p.m, and most probably like the earliest I can start again is 6 p.m. The earliest. We'll see because I wanna go for a walk too. So we have 2 minutes left. So like it was amazing, guys. It was amazing study together with you. Today we have solved a bunch of leetcode problems and we studied Java. That was amazing. We can like I will wrap up these two. Like we've seen a lot of classes, and we've written like some controller classes, service classes, like different packages. We basically now can using HTTP we can send request, accept it, process it, and return. One of the most important thing we studied today here is this method, this brilliant method, because it does amazing stuff. It takes this optional account, guys. Like this is something crazy for me, guys. Optional account, and return a real account basically. But the reason why I say magical is that like look at it, guys, look at it. Um, the let's say the element, like the argument it gets is this, and like look at the return type. This means any class that is child of throwable, all right? Uh, child of throwable. So, and when we look at the return type of find by ID, we see optional, and when we look at optional class, uh, we don't see anything. Optional. Uh, in optional, like, so we are in optional basically. Like this is what I mean. In optional class, we have this method, all right, and the return type of it is anything throwable. Is account throwable, guys? Entity. This is the last question, all right? Is account throwable? Because yeah, so this method, because this method returns this one, but the way we use is like a relay account. Or guys, throwable, it can be throwable because if we don't find, we really throw an exception. This is why. But when we find, uh, we return value. Which value? Let's just look at. Uh, which value? Oh my gosh, which value? Let's look at it. Which value? This value. This value is type T. So yes, so optional T. So we basically return value, and the type of value is T, optional T. Optional T. So find by ID returns optional T. All right. All right. So basically, we get either what this method returns or an error throwable. So the way we type this as throw is this one. Actually, guys, now I see. We don't have only one thing here. We have like a throwable as a one, I think, option, like a return option, and T also. Let me ask these two, and then we are gonna end this stream, guys. Before moving on, I just want to ask you that is this method return type is like a, does this mean it can return uh, a class that extends throwable and as well as T, or only throwable? So what is the convention here? Like, because this is the first time I see that a method returns two types, because I thought that methods can return only one type. Let's see, guys, let's see. This is the last question. Because like method returns two types, that's quite interesting. Because we literally return value, and when we look at the value, it is option T, and this T coming from this. Let's see. Come on, come on, come on, come on, come on, come on. Please say yes. Good catch to pass here, but you are misreading. Oh my gosh. This method returns exactly one type, T. X is not the second return type. Let me break the signature into its four distinct parts. So, type parameter declaration. Like, how do we make this bigger? Return method, like this is method params, throws. So public access modifier, type parameter declaration. For this call, there is a generic type X, and it must be subtype. For this call, there is a generic type X. But which part of this code? Haha, wrong answer, extend fast. Yeah. So T is return type, the only thing return, or as throw name and parameters, the checked exception this method may throw. Oh, I see. Like this literally says that we have something called x, and it is child of throwable, and the x we use here, guys, is this one, throws x, and this is this basically. All right, and that x is coming from here. We literally, like, it is like we can literally set the exception as a parameter. All right, I thought this is return type, but this is not. The return type is t. What is t? It is optional. It comes from optional t. How do we set that t? Because we set x from parameter. But how do we set t? Let's see. Which method we were talking about? So in transfer. So how do we set option t? I guess it has something to do with this method, and this is CRUD repository. This returns optionality. Like, how do we exactly? Where do we exactly like where exactly is this t getting set? This is this one, and it is all right. Find by ID. We, I guess, guys, this find by ID. So let me ask this one too. This is literally last question. Last question. All right, all right, all right, all right, all right. All right, this one. So this is from CRUD repository class. and and the line I am trying to understand is, so my question is that, like, when I open find by ID, I see t, like it, like this method returns optional t basically, which is amazing. But the thing I wonder is, where do we exactly set this t? Because, like, I'm asking this because, for example, in or else throw method, um we literally, like, as far as I know, we set x here using the parameter. All right, because the exception supplier parameter, um like, I assume that way actually. Like, can you clarify? Because there are different ways to set these generics, and this or else throw method returns value, and that value has optional t. So, and also in or else throw method we give functional interface, and any class that extends x. So it means child of x and throws x. Could you please clarify that? I feel a little bit lost over here. Like, I, like, the thing I want to understand is, where do we exactly set, like, when does this t gets its value? All right, this is what I'm asking. Because, like, is it because of the type of the variable we give, or like how exactly? Let's see. You're not lost. You actually spotted the real thing. T and X are bound in two completely different places by two different mechanisms. The whole inside, that's the whole inside. Let me separate them. Two scopes where a generic lives. Interface type parameter, method type parameter. So T on CRUD repository TID belongs to the interface. Its scope is the whole interface. X on Orastro. Let's open it. Belongs to the method. This belongs to the method. I was loose. To stack frame. Yeah. So belongs to the method. Its scope is just that method call. Different owner, different moment of binding. Different owner, different moment of binding. Alright. Where tag gets set at the implementation, not the call. Very nice, guys. Very nice. Not the call. T is fixed. The moment you wrote your rep. Oh my gosh. The moment you wrote your repository interface. So, like we are not even writing the implementation of that interface, but we have interface that extends other interface that doesn't matter. But the moment we write our interface, let's look at our interface. Where is our interface, guys? I think account repository, and let's look at account repository. So account repository is, I think, this one. Let's look at it. And T and ID, and it shares, I think, this TID with this TID. So when we open this, is this where we were? Anyway, so the important thing is, as we as we type an interface, not the implementation, the interface itself, we determine our type. This is brilliant. So public account extend GPA repository account. So T is account, ID is long. Wonderful. By extending GPA repository, yes, like we literally extend this. Yes. So it means that we set our T as account and an ID as long. All right. For the entire interface. Once from that point on, every inherited method that mentioned T is reread with account substituted in. So in GPA repository, guys, we have find by ID. All right, so that ID will belong. Yes, so that ID will belong. Template in CRUD repository. What account repository actually exposes? So optional T find by ID, and that returns into account. As we type this interface, guys, like our interface now is kind of custom version of that interface, and in that interface, T is, so we literally create an interface just for setting these. All right, in GPA repository, these were T and ID, but we set account and long basically. All right. So when you call account repository find by ID from ID, you get optional account, not because of any argument you passed. This is the answer I was looking for. Not because of any argument that I passed, but because T was already nailed to account back at the extends line. You set T by choosing what to put inside the angle brackets when you extended an interface. This is the same as yeah. All right. So we basically start using methods that we have here in this GPA repository. On top of that, we basically fill this T and ID with what we want. We want account and long because we want to basically save account in our database. If we want to save, let's say, a tree or a car, a machine in our database, this would be machine basically, and this is the ID. So like tree and ID or machine and ID. That's awesome. That's awesome. So this is the same as new array list. Oh, that's awesome. So we literally assign t as string and string bound here at construction list add x, so add t read as add string. Oh my gosh, this is wonderful. This is wonderful. T is a class interface level parameter. All right, so basically guys, I almost fully understood it. All right, so now I'm ending this team, guys. It was great working with you. I think I need to wrap up here. um, See you in our next stream, which is gonna be tomorrow at 4 a.m. All right, in UTC 3 time. Thank you for being here. I hope you find meaningful and helpful stuff over here because I do. I wish you luck in your studies. Take care, guys. And yeah.